For centuries, historians believed the ancient world was simple and predictable. Civilizations rose, built cities, and slowly advanced through trial and error. But every year, archaeology reveals discoveries that challenge this narrative. Perfectly aligned temples appear in places once thought technologically primitive. Massive stone blocks weighing dozens of tons were moved and fitted together with astonishing precision. Ancient artifacts hint at knowledge of astronomy, mathematics, and engineering far beyond what historians expected for their time. These mysteries force us to reconsider a fundamental question: how advanced were ancient civilizations really? As new excavations continue to uncover forgotten sites and unexplained technologies, it becomes increasingly clear that the story of the ancient world may be far more complex than the history books suggest. Blaundos ancient city is one of the lesser-known ancient cities, yet it carries many unanswered questions about ancient engineering and construction techniques. The city sits on a rugged rock plateau in western Anatolia, in what is now modern-day Turkey. What makes Blaundos remarkable at first glance is its almost isolated geographical position. Three sides of the city are surrounded by steep cliffs dropping hundreds of meters, making the entire area resemble a massive natural fortress. Only a few narrow routes connect the plateau to the surrounding land. Because of this strategic position, many researchers believe Blaundos once served as a defensive stronghold in the ancient world. However, when examining the remaining ruins more closely, it becomes clear that this difficult terrain also raises an important question about how the city was actually built. In order to construct a fully functioning urban settlement on top of this rocky plateau, ancient inhabitants had to transport a vast amount of building material, especially the heavy stone blocks used for city walls, gateways, homes, and public structures. In an era without hydraulic cranes, trucks, or mechanized lifting equipment, moving such massive stones to a high and difficult location would have been an extremely challenging task. Archaeologists have proposed several possibilities, including the use of sloped access roads, pulley systems, or wooden sledges pulled by people or animals. Yet even with these methods, the scale of construction at Blaundos still raises a lingering question. How could an ancient community organize and complete such a large building project on a plateau that was nearly isolated from the surrounding landscape? What truly makes Blaundos mysterious, however, is not only its location, but also the remarkably precise stoneworking techniques visible throughout many of the city's structures. When archaeologists began studying the walls and foundations of Blaundos, they discovered that many of the stone blocks had been cut with astonishing flatness and precision. The edges of the stones are often sharply defined, and the contact surfaces between blocks appear to fit together almost perfectly. In many sections of wall, the gap between adjacent stones is so small that it is nearly invisible to the naked eye. In some cases, the stones are placed so tightly together that it is difficult to insert even a thin object between the joints. This level of precision becomes even more remarkable when considering the tools that ancient craftsmen likely used. During the Hellenistic and Roman periods, the most common tools for stone working were metal chisels, hammers, and wedges. While these tools were certainly capable of shaping stone, achieving nearly perfectly flat surfaces and consistent edges across hundreds of blocks would have required extraordinary skill. Each craftsman would have needed to carefully control the force of every strike while maintaining the straightness of the stone surface, all while ensuring that each finished block would align precisely with others in the structure. One theory suggests that many of these stone blocks may have been cut and prepared at nearby quarries before being transported to the construction site. If that were the case, the ancient builders must have relied on highly accurate measurement systems to ensure that stones shaped at a quarry would still fit perfectly when assembled at the building location. This implies the use of precise methods for measuring length angles and surface flatness, even though modern measuring instruments did not yet exist. Another interesting detail is that many walls in Blaundos do not rely solely on stones of identical size. Instead, stones of varying dimensions are fitted together in a surprisingly effective way, forming stable and durable structural walls. This suggests that the builders were not only capable of cutting stones with precision, but also had a sophisticated understanding of how weight distribution and compressive forces work within stone architecture. If the blocks had not been shaped accurately or positioned correctly, the walls could have gradually become unstable over time. The fact that many of these stone walls at Blaundos have remained standing for thousands of years demonstrates how effective the ancient construction techniques truly were. Over the centuries, the region has experienced earthquakes, temperature fluctuations, and natural erosion. Such environmental forces typically cause stone structures to crack, weaken, or collapse. Yet many of the structures at Blaundos have retained their form, suggesting that the stones were joined together with remarkable precision and stability. Because of this, the stone cutting and masonry techniques seen at Blaundos are often considered evidence of the impressive engineering capabilities of ancient civilizations. At the same time, they also raise several intriguing questions that still lack definitive answers. How were ancient craftsmen able to produce such flat and uniform stone surfaces using only hand tools? Did they rely on specialized geometric methods to measure and shape each block? And could there have been ancient stoneworking techniques that modern researchers have not yet fully understood? Beyond its stone construction techniques, Blaundos also draws attention for its system of water storage reservoirs built on the plateau. Because the city sits at a high elevation and lacks a major nearby natural water source, its ancient inhabitants had to find ways to collect and store rainwater. Large stone-built cisterns were constructed to capture and preserve this water supply. These reservoirs were often coated with special waterproof materials, allowing them to retain water for long periods of time without significant leakage. This system demonstrates that the people of Blaundos possessed considerable knowledge about water management in a challenging environment. By carefully storing rainwater, they were able to sustain a community on a plateau where natural water resources were limited. Archaeological investigations at Blaundos have also revealed signs of underground structures, including chambers and possible tunnels beneath parts of the city. The exact function of these underground spaces remains uncertain. They may have been used for food storage shelter during times of conflict, or perhaps as part of a broader infrastructure system related to water storage or drainage. However, since many areas of the site have not yet been fully excavated, the true purpose of these underground structures remains something of a mystery. Despite being built on a rugged and uneven rock plateau, Blaundos still shows evidence of organized urban planning. Streets, residential areas, and public buildings appear to have been arranged in a relatively logical layout within the limited space available on the plateau. This suggests that the builders of the city possessed not only construction skills but also a strong understanding of spatial planning and urban organization. Designing and constructing a city in such a challenging environment would have required careful surveying and planning, further highlighting the technical capabilities of the people who built Blaundos. All of these elements combine to make Blaundos ancient city a fascinating archaeological site. It does not simply represent the remains of an ancient settlement, it also reveals the impressive technical abilities of the people who once built and inhabited it. From its nearly inaccessible geographical location to the astonishing precision of its stone masonry to its water management systems and urban planning, Blaundos presents a complex picture of ancient engineering. Perhaps that is why Blaundos continues to capture the interest of researchers today. Every precisely cut stone, every wall that has stood for thousands of years seems to quietly pose the same question. Have we truly understood all the techniques and knowledge that ancient civilizations once possessed? How do you think ancient builders were able to cut and fit massive stone blocks with such precision using only simple tools? Share your thoughts in the comments below. Saimalu-Tash Petroglyph Valley is one of the most mysterious and impressive archaeological sites in Central Asia. Located on the slopes of the Fergana mountain range at an altitude of more than 3,000 meters above sea level, the valley contains tens of thousands of ancient carvings spread across countless dark basalt boulders. Archaeologists estimate that the number of petroglyphs here may reach many tens of thousands, created over several millennia from the Bronze Age to the medieval period. However, what makes Saimalu-Tash remarkable is not only its immense scale, but also the technical mysteries surrounding how ancient people created these carvings. Among all the unanswered questions, one of the most astonishing aspects is the technique of carving into extremely hard stone, a process that is not always simple, even with modern tools. Basalt, the type of rock that makes up most of the stones at Saimalu-Tash, is a very hard volcanic rock. On the Mohs hardness scale, basalt has a relatively high hardness, making carving or engraving it with primitive tools extremely difficult. However, when observing the petroglyphs at Saimalu-Tash, researchers notice that the engraved lines often have fairly consistent depth, relatively smooth surfaces, and in many cases display quite delicate details. Some carvings depict hunting scenes, herds of animals, religious rituals, and even complex geometric symbols. What is particularly striking is that these lines are not always rough, like random impact marks. Many figures show a remarkable control of line curvature and proportion. This leads researchers to ask an intriguing question: what tools did ancient people use to carve such precise lines into a rock as hard as basalt? According to the traditional hypothesis, ancient artisans may have used the pecking technique, meaning they repeatedly struck the basalt surface with a harder stone until small pits formed and gradually combined into a recognizable image. This method has been documented in many prehistoric cultures around the world. However, when this hypothesis is applied to Saimalu-Tash, a problem emerges. To create large carvings with clear outlines using the pecking method, the artisan would have to perform thousands or even tens of thousands of small strikes. This would require an enormous amount of time. When this effort is multiplied by the tens of thousands of petroglyphs found across the valley, the total time required becomes almost unimaginable. Furthermore, many petroglyphs at Saimalu-Tash display smooth curves and small details, features that are sometimes difficult to achieve through simple stone pecking alone. Some animal figures, such as mountain goats, deer, or wild cattle, are carved with fairly balanced and recognizable proportions. In some cases, nearly perfect circles can also be observed, along with geometric symbols that display notable symmetry. If these images were truly created using simple stone tools, the skill of the artisans must have been extraordinarily high. Another intriguing feature is the remarkable consistency of many carved lines. When archaeologists closely examine the surfaces of certain petroglyphs, they notice that the depth of the carvings often remains relatively uniform along the entire figure. This suggests that the individual performing the carving had a precise control of both force and placement. Considering the harsh mountain environment, with strong winds and fluctuating temperatures, maintaining such precision over long periods would not have been easy. The location of Saimalu-Tash adds another layer of mystery. The valley lies at a high altitude where winters are long and living conditions are extremely harsh. To produce tens of thousands of petroglyphs in such an environment, ancient communities would have had to return to this location repeatedly over centuries or even millennia. This suggests that Saimalu Tash may once have held special significance, perhaps serving as a ceremonial center, a seasonal gathering place, or a sacred site for nomadic cultures in the region. Researchers have also noted that the surfaces of basalt stones at Saimalu Tash are often covered with a dark patina layer formed over long periods through weathering. When ancient artisans carved into this surface, the patina was broken, revealing a lighter-colored layer of stone beneath. This contrast made the carvings stand out clearly against the surrounding rock. However, over time, a new patina gradually formed over the carved lines, darkening them again. This process allows archaeologists to estimate the relative age of some petroglyphs while also indicating that the carvings were likely created during many different periods spanning thousands of years. Despite ongoing research, many questions remain unresolved. For example, were all the petroglyphs created using the same technique? It is possible that different communities living in different time periods used different methods to carve the stones. Yet direct archaeological evidence of the specific tools used at Saimalu Tash remains limited. Another mystery involves the precision of certain carvings. While most petroglyphs have a relatively simple artistic style, some figures display a surprisingly balanced and deliberate composition. This has led some researchers to wonder whether the artisans used preliminary marking techniques before carving. For instance, they might have sketched guiding lines on the rock surface before beginning the engraving process. However, after thousands of years, any traces of such preparation would likely have disappeared. Viewed as a whole, Saimalu Tash is not simply a collection of ancient rock art. It resembles a vast visual archive of prehistoric cultures. Each stone may tell a story about the daily life beliefs and worldview of the communities that once passed through this valley. Yet the deeper researchers investigate, the more they realize how much remains unknown. The technique of carving into extremely hard basalt, the enormous number of petroglyphs, the diversity of symbols, and the harsh geographic conditions of the valley all combine to make Saimalu Tash one of the most mysterious archaeological sites in Central Asia. And despite many proposed explanations, a fundamental question still remains. How were ancient communities with limited tools and technology able to create tens of thousands of precise carvings on hard basalt in such a challenging environment? Perhaps in the future, as new analytical technologies are applied and more detailed surveys are conducted, we will gain a clearer understanding of the techniques used at Saimalu Tash. Until then, this petroglyph valley continues to raise fascinating questions for archaeologists and for anyone intrigued by the enduring mysteries of the ancient world. In your opinion, how were ancient people, with very limited tools and technology, able to carve tens of thousands of detailed images into hard basalt rocks at an altitude of more than 3,000 meters? Do you think this was simply the result of extraordinary craftsmanship developed over many generations? Or could there have been ancient techniques that we still do not fully understand today? Share your thoughts in the comments below. Your perspective might offer a completely new way of looking at this ancient mystery. On a jagged, rocky island, rising from the violent waters of the Atlantic Ocean, about 12 kilometers off the western coast of Ireland, there exists a small but mysterious architectural complex. These are the beehive huts on the island of Skellig Michael's stone dwellings, shaped like beehives, built by Christian monks sometime between the 6th and 8th centuries. At first glance, they appear extremely simple, just piles of stone stacked into low domes. But when examined more closely, archaeologists and modern engineers have realized that these structures contain a remarkable level of technical sophistication, particularly in their self-supporting stone dome architecture with almost perfect precision. The first thing that surprises researchers is the construction method used for these huts. The beehive huts were built entirely using dry stone construction, meaning no mortar or binding material was used at all. Each stone is held in place only by gravity and the precise way it fits with the surrounding stones. In many other ancient structures, even the most advanced stonework usually relied on mortar to fill gaps. But on Skellig Michael, there is no such bonding layer. The stones were carefully shaped or selected so that they fit together almost perfectly, forming a highly stable, self-locking structure. The secret lies in the special form of their roofs, a technique known as a corbelled dome. Instead of creating arches using wedge-shaped stones, as seen in Roman architecture, the builders placed each layer of stone horizontally, with every layer slightly projecting inward compared to the one below it. As this process continued upward, the stones gradually moved closer toward the center until the dome finally closed at the top. The result was a completely self-supporting stone dome, requiring no internal columns or supporting framework. What makes this truly astonishing is the level of precision required. If each layer projected inward too far, the dome would collapse. If it projected too little, the dome would never close. Today, engineers can simulate this structure using computer models and have found that the angle of the stone layers in the beehive huts is remarkably close to optimal force distribution values. This means the entire weight of the dome is transferred downward through the walls in an extremely stable way. What is astonishing, however, is that the builders of these huts had no formal knowledge of mathematics, no architectural blueprints, and no modern measuring tools. They had only stone simple tools and practical experience. Standing inside a beehive hut reveals another remarkable feature. The stones are arranged in perfect circular layers, one above another, resembling ripples spreading across water. There is no obvious misalignment. Small gaps between stones are positioned in such a way that rainwater can hardly penetrate the interior. Even in the harsh Atlantic climate, where strong winds and heavy rainfall are frequent, the huts manage to remain surprisingly dry inside. This suggests that the builders understood how to direct rainwater along the surface of the stone roof, a waterproofing principle still used in modern construction. Another mystery lies in the durability of these structures. The beehive huts have stood for more than 1,200 years, enduring countless ocean storms. Winds from the Atlantic can reach extreme speeds, and sea salt is capable of eroding many materials over time. Yet these stone domes remain standing. There are no wooden frames inside, no metal reinforcements, and no mortar that could deteriorate with age. The entire structure is simply stone, stacked upon stone. Yet it has proven astonishingly resilient. Archaeologists have also raised questions about the construction process itself. Skellig Michael is a steep rock formation. To reach the monastery site, one must climb hundreds of stone steps carved into the mountainside. So how did the monks transport tons of stone to the construction area? There is no evidence of cranes, large pulley systems, or mechanical lifting devices. It is possible that they simply carried each stone by hand, but that would have required an enormous amount of labor and time. Even the selection of stones raises questions. The stones used in the beehive huts have sizes and shapes extremely suitable for dome construction. This suggests the builders were not simply picking up random rocks. They had to carefully select and rotate each stone to achieve the best possible fit. In many cases, a smaller stone was placed precisely in position to lock larger stones together, functioning like a keystone within the structure. Some researchers believe this technique may be the result of a long-standing architectural tradition in Ireland and Scotland. Similar stone huts known as clochans have been discovered in other locations. However, the beehive huts on Skellig Michael stand out because of their exceptional level of refinement and durability. Built in an extremely inaccessible location, they nevertheless display a technical quality comparable to major stone structures found on the mainland. The arrangement of the huts within the monastery also reflects careful planning. They are placed on natural terraces of the mountainside, using the terrain to reduce exposure to strong winds. Low stone walls surround the living area, creating small courtyards between the huts. All of these elements suggest that this was not a temporary settlement, but rather a deliberately designed architectural system. The greatest question, however, concerns the technical knowledge of the builders. To create a complete corbelled dome, one must understand at least three important principles: the distribution of weight, the angle of each stone layer, and the locking point at the top of the dome. In later architectural traditions, these principles are often explained through mathematics and geometry. But on Skellig Michael, they appear to have been applied without any surviving technical documentation. Did the monks learn this technique from an even older architectural tradition, or did they develop it through experimentation and experience across generations? And if that is the case, why were these construction methods never recorded in the monastic manuscripts that preserved so much other knowledge? Today, when researchers stand before these ancient beehive huts, they often feel that their simplicity is deceptive. Beneath their rough exterior lies an incredibly sophisticated structural system where every stone plays a role in holding the entire dome together. The combination of technical precision, remarkable durability, and an extremely harsh geographic setting has turned these small stone huts into one of the most fascinating architectural mysteries of the ancient world. And even today, as the Atlantic winds continue to sweep across the cliffs of Skellig Michael, those stone domes still stand there silent and resilient, as if guarding a technical secret that history has not yet fully understood. How do you think the ancient monks on Skellig Michael were able to build such precise and durable, self-supporting stone domes? Share your thoughts in the comments below. The Kostenki's circular dwellings are among the most unusual and thought-provoking prehistoric structures ever discovered. Located near the village of Kostenki in western Russia, along the banks of the Don River, these ancient constructions date back roughly 25,000 years to the depths of the last ice age. At first glance, they may appear to be simple accumulations of bones scattered across the frozen landscape of prehistory. Yet when archaeologists began to excavate the site carefully, a far more remarkable picture emerged. What they uncovered were not random deposits of animal remains, but enormous circular structures built deliberately from the bones of mammoths. These circles, some measuring between 9 and 12 meters in diameter, were constructed using the skulls, jaws, ribs, and long limb bones of dozens of mammoths. In several cases, the remains of more than 60 animals were used in a single structure. The scale alone is astonishing. For small hunter-gatherer communities living in an Ice Age environment, with stone tools and limited resources, the ability to collect, transport, and arrange such a massive quantity of bone suggests an unexpected level of planning, cooperation, and technical understanding. The very existence of these structures raises immediate questions. Mammoths were enormous animals, and many of their bones could weigh hundreds of kilograms. Moving them across frozen ground would have required significant effort and coordination. Yet the bones were not simply piled together. Instead, they were placed carefully in circular patterns, forming what appears to be a deliberate architectural design. Archaeologists have found mammoth skulls positioned along the outer perimeter, acting almost like structural anchors or foundational elements. Long bones were placed in layers or arranged vertically, possibly functioning as supports for additional materials that no longer survive. Within the circles, excavations have revealed traces of hearths, ash deposits, and pits that may have been used for storage or food preparation. These details suggest that the structures were more than symbolic constructions. They may have served as shelters, gathering places, or communal centers during the harsh winters of the Ice Age. However, among all the mysteries surrounding the Kostenki circular dwellings, one aspect stands out as particularly striking: the geometric precision of the circular layouts. When archaeologists mapped the structures carefully, they noticed something unexpected. The bones forming the outer boundaries were arranged in shapes that closely approximate true circles. These were not irregular enclosures or accidental shapes created by scattered materials. Instead, they formed coherent geometric patterns that maintain a relatively consistent distance from the center across the entire perimeter. In some cases, the circular outline is so clear that it can be recognized immediately even from aerial views of the excavation site. This raises an intriguing question. How did people living 25,000 years ago achieve such geometric consistency without any known measuring tools, mathematical instruments, or formal knowledge of geometry as we understand it today? Creating a circle of that size with consistent curvature is not a trivial task. Even in the modern construction, maintaining geometric accuracy across a 10-meter diameter requires planning and reference points. Builders must decide where the center lies and ensure that each part of the perimeter remains roughly the same distance from that center. One possibility is that the ancient builders used a simple but effective technique. They may have placed a stake in the center and used a cord or length of sinew to mark the radius, tracing a circular boundary on the ground before arranging the bones. This method, essentially an early form of compass construction, is theoretically possible even with simple materials. Yet there is no direct evidence that such tools were used. No preserved ropes or central stakes have been found, and the archaeological record rarely preserves organic materials from such remote periods unless conditions are exceptional. Another possibility is that the circular shapes emerged gradually through repeated adjustments during construction. Builders might have begun with a rough enclosure and then refined the arrangement as they placed additional bones. However, this explanation raises further questions. Achieving a smooth and balanced circle through trial and error alone would likely produce uneven or distorted outlines. The Kostenki circles, by contrast, often show a surprising degree of regularity. The perimeter bones appear to have been placed deliberately, with a sense of symmetry, suggesting that the builders had some intuitive or practical understanding of spatial organization. The geometric nature of these structures also invites speculation about their function. Circular architecture appears in many cultures throughout human history, often because it distributes structural forces evenly and can be constructed efficiently using available materials. In a harsh Ice Age environment, a circular shelter covered with animal hides and supported by mammoth bones might have provided stability against strong winds and heavy snow. The shape could also help retain heat by minimizing exposed surface area relative to the enclosed space. If these structures were indeed dwellings, the circular layout may represent an early example of practical engineering emerging from the demands of survival. Yet the mystery deepens when we consider that not all Kostenki circles show clear evidence of long-term habitation. Some contain hearths and signs of daily activity, but others appear relatively clean, lacking the debris typically associated with living spaces. This has led some researchers to suggest alternative explanations. Perhaps certain circles served as communal gathering places where groups met during seasonal migrations. Others might have functioned as storage areas for meat and fat during times of abundance. There are even suggestions that some of the structures could have had ritual or symbolic significance. The circular form itself has often been associated with cycles of nature, the movement of the sun, or the organization of social space. While there is no direct evidence linking the Kostenki circles to ritual activity, the possibility cannot be ruled out entirely. The use of mammoth bones as construction material also presents its own technological puzzle. During the Ice Age, wood was scarce across large parts of the steppe landscape surrounding Kostenki. Trees grew sparsely in the cold climate, making large wooden structures difficult to build. Mammoth bones, however, were abundant wherever mammoths were hunted or scavenged. Their size and strength made them suitable for building frameworks. Archaeologists believe that the bones may have formed the base of the structures, while additional elements such as wooden poles, branches, and animal hides created the upper walls and roofs. Over thousands of years, these organic materials decomposed, leaving behind only the durable bones arranged in their original patterns. Even so, the logistics involved in gathering the bones remain difficult to explain. If a single circle required the remains of dozens of mammoths, it raises the question of how those animals were obtained. Did the builders hunt them directly, or were the bones collected from natural death sites? Over many years, mammoth hunting would have been extremely dangerous and required coordinated group effort. If the bones were gathered gradually from scattered locations, transporting them across the landscape would have been equally challenging. Either scenario implies a level of planning and resource management that goes beyond the stereotypical image of small, loosely organized hunter-gatherer bands. In recent years, advanced scientific techniques have begun to shed new light on the Kostenki site. Researchers have analyzed plant remains, charcoal fragments, and microscopic traces preserved in the soil. These studies suggest that the inhabitants were not only burning wood and bone for fuel, but may also have processed plant materials inside the structures. Seeds and plant fibers found at the site indicate that Ice Age communities were experimenting with a wider range of resources than previously assumed. This discovery adds another layer to the technological sophistication of the people who built the circular dwellings. Despite many advances in science, the greatest mystery of the Kostenki circular dwellings still remains unsolved. In particular, the geometric precision of the circular structures continues to raise questions about the technical abilities of humans during the Ice Age. Were these structures simply the result of practical experience from hunting groups adapting to a harsh environment, or do they reflect an ancient form of spatial knowledge passed down through generations, allowing people to build complex structures without measuring tools or formal mathematics? Whatever the answer may be, the mammoth bone circles at Kostenki remind us that human creativity and technical thinking existed long before the rise of great civilizations. Even today, their geometry still poses a profound question: how much did prehistoric humans truly understand about architecture and space, and how much of that knowledge has been lost over time? How do you think humans more than 25,000 years ago were able to create such remarkably precise circular structures? Share your thoughts in the comments below. The ancient site Arkaim lies across the vast grasslands of the southern Ural steppe, near the modern border between Russia and Kazakhstan. At first glance, Arkaim appears to be nothing more than faint circular patterns on the ground. However, when archaeologists studied the site more carefully, they discovered beneath the soil the remains of a highly unusual Bronze Age settlement. It was a deliberately designed circular city with such a balanced and organized layout that it raises questions about the technological capabilities of the people who built it nearly 4,000 years ago. Arkaim is believed to have been constructed between the 20th and 17th centuries BCE, during a time when many Eurasian societies were still forming early settled communities. While most Bronze Age villages developed gradually over time with rather irregular layouts, Arkaim was completely different. The entire settlement was built according to a clearly planned circular design from the very beginning, leading many researchers to view it not simply as an ancient village, but as a deliberately engineered and organized urban structure. The most remarkable aspect of the settlement is its extremely precise circular geometry. When viewed from above, the entire city forms two concentric rings. The outer ring consists of a thick defensive wall that once stood several meters high, constructed from packed earth timber and clay. Just inside this wall stood a continuous row of houses arranged in a perfect circle. These houses were not randomly placed. Each one followed the curvature of the outer wall, creating a ring of living spaces that formed a continuous architectural band around the city. Inside this first ring lies a second circular wall, creating another enclosed zone. Between the two rings were narrow streets and passageways that connected the houses and allowed movement throughout the settlement. At the center of the entire structure lies an open circular plaza, forming the geometric heart of the city. From a structural perspective, the entire settlement resembles a giant wheel. The outer ring forming the rim, the inner ring acting as a second boundary, and radial pathways connecting different sections of the city. What makes this design particularly mysterious is the level of geometric accuracy involved. The diameter of the settlement is roughly 170 meters, and the spacing of the houses along the circular walls is remarkably uniform. The curvature of the walls appears consistent throughout the entire structure, suggesting that the builders were following a predetermined plan rather than improvising as construction progressed. This raises a fundamental question: how did Bronze Age builders achieve such precision? To create a circular settlement of this scale, the builders would first need a method to establish a perfect center point. From that point, they would need to measure equal distances outward in all directions to define the circumference of the outer wall. Even a small error in measurement could distort the circle significantly when expanded across such a large diameter. Yet archaeological surveys show that the structure remains remarkably symmetrical. One possibility is that the builders used a simple but effective surveying technique involving ropes and stakes. By fixing a central stake and stretching a rope of constant length while marking points along the ground, they could theoretically trace a circle. However, doing this accurately across uneven terrain and maintaining consistency across hundreds of meters would require careful planning and coordination. It would also require an understanding of geometry that many historians previously assumed was beyond the capabilities of most Bronze Age communities. Another puzzling element is the modular organization of the houses within the circular structure. Each dwelling appears to have been constructed using a similar blueprint. Many houses share comparable dimensions, internal layouts, and structural features. The entrances of these houses often faced inward, toward the central plaza, suggesting that the entire settlement was oriented around communal space rather than outward expansion. This arrangement hints at a highly organized society capable of planning an entire settlement before construction began. In many ancient communities, cities grew gradually over generations. Arkaim, however, appears to have been constructed according to a single architectural concept. The uniformity of the houses and the symmetry of the circular design strongly suggest that the builders followed a centralized plan from the very beginning. From a defensive standpoint, the circular structure also makes strategic sense. Circular fortifications eliminate blind corners and distribute structural stress evenly across the walls. Defenders positioned along the perimeter would have had a continuous line of sight along the curve of the wall, making it easier to monitor approaching threats. This suggests that the builders understood not only geometry, but also the defensive advantages of circular architecture. Yet the mystery deepens when we consider the tools available at the time. The people who built Arkaim lived during the Bronze Age, when metal tools were relatively simple and surveying instruments were primitive by modern standards. There is no evidence that they possessed advanced measuring devices or mathematical texts describing circular geometry. Despite this, the settlement demonstrates a level of planning that resembles later urban engineering traditions. Some researchers have proposed that the circular design may also have had symbolic or cosmological significance. In many ancient cultures, the circle represented order, harmony, and the structure of the cosmos. The central plaza could have served as a ceremonial space, possibly linked to rituals, gatherings, or astronomical observations. If this interpretation is correct, the geometry of Arkaim may have reflected not only practical considerations, but also deeper cultural ideas about the universe. Another intriguing possibility is that the settlement was aligned with celestial events. Certain researchers studying the orientation of the walls and entrances have suggested that specific points in the structure correspond to the positions of the sun during the solstices and equinoxes. If these alignments are intentional, Arkaim may have functioned as a kind of large-scale astronomical observatory integrated directly into the layout of the city. If that is the case, the precision of the circular design becomes even more impressive. Aligning architectural structures with astronomical events requires careful observation of the sky over long periods of time. The builders would need to track the sun's movement across the horizon and incorporate those observations into their construction plans. For a Bronze Age society, this would imply a sophisticated understanding of seasonal cycles and celestial patterns. Beyond its geometry, Arkaim also reveals evidence of advanced infrastructure within the houses themselves. Archaeological excavations have uncovered traces of furnaces, ventilation channels, and drainage systems built into the structures. These features suggest that the settlement was not only carefully designed on the outside, but also engineered internally to support specialized activities such as metallurgy. Many of the houses appear to contain small furnaces that may have been used for metalworking. These furnaces were connected to underground channels that allowed air to flow through the structure, increasing combustion efficiency. This indicates that the inhabitants possessed practical knowledge of airflow and heat control. The integration of these systems into the architecture of the houses suggests that the entire settlement was designed with industrial activity in mind. The greatest mystery of Arkaim remains the extremely precise circular layout of the entire city. Even when analyzed with modern mapping technology, the structure of Arkaim continues to impress archaeologists and engineers. The symmetry and uniformity of the circular walls and residential sections clearly suggest that the settlement was built according to a deliberate architectural plan. This raises an important question: who designed Arkaim and how did they accomplish it? Nearly 4,000 years ago, did the builders possess practical geometric knowledge passed down through generations, or did they use surveying techniques that have since been lost to history? Although the site has been studied for decades, Arkaim still challenges our understanding of the technological capabilities of Bronze Age societies. And even today, one central question remains unanswered. How could an ancient civilization design and construct such a perfectly circular city with such high precision thousands of years ago? High above the rolling landscape of Aberdeenshire in northeastern Scotland stands the mysterious hill known as Tabula Peutingeriana. Rising more than 500 meters above sea level, this isolated summit was once the site of a large Iron Age fort. At first glance, the ruins scattered across the hill appear similar to many other ancient hill forts found across Britain. Low stone walls trace the outline of the old defensive enclosure, and fragments of rock lie scattered across the ground. Yet when archaeologists began to study the site more closely, they discovered something extraordinary hidden within the structure of the walls themselves, evidence that parts of the stone fortifications had once been heated to such extreme temperatures that the rock had partially melted and fused together. This phenomenon, known as vitrification, is what makes the vitrified fort of Tabula Peutingeriana one of the most puzzling archaeological sites in Europe. Unlike ordinary stone walls that are simply stacked or mortared together, sections of the fort's defenses appear as though the stones have been welded into a single solid mass. The surfaces of many rocks have melted and flowed, binding neighboring stones together in a glass-like structure that resembles slag from a furnace. In certain places, the stones appear almost glued together, with melted mineral material filling the gaps between them and hardening into a dense fused layer. The most remarkable aspect of this phenomenon lies in the extreme temperatures required to produce it. Granite and other stones found at the site typically begin to soften and vitrify only when heated to temperatures approaching 1,000 to 1,200 degrees Celsius. Such conditions are comparable to those used in modern industrial furnaces for smelting metal or producing glass. Achieving these temperatures in a controlled environment requires concentrated fuel insulation and careful management of airflow. Yet the people who built Tabula Peutingeriana lived more than 2,000 years ago during the Iron Age, long before the development of advanced furnaces capable of producing such sustained heat on a large scale. This raises one of the most intriguing technical mysteries surrounding the site. How were ancient builders able to generate enough heat to partially melt massive stone walls? The vitrification visible at Tabula Peutingeriana is not confined to a single stone or a small section of the wall. Instead, large portions of the defensive structure show signs of intense heating. For the stones to fuse together in this way, the fire would have needed to reach and maintain extremely high temperatures across wide stretches of the wall. Producing such heat in open air using only wood as fuel would have required enormous quantities of timber and careful organization. One hypothesis proposed by archaeologists is that the vitrification was intentional. According to this theory, the builders of the fort deliberately burned the walls after construction in order to strengthen them. By heating the stones until their outer layers melted slightly, the rocks would fuse together as they cooled, forming a single cohesive structure. In theory, such a wall might be more resistant to structural collapse or attempts to dismantle it. The melted mineral material could act like a natural adhesive, locking the stones into place. However, attempts to replicate this process in modern experiments have produced mixed results. Experimental archaeologists have tried building small stone walls and heating them with large fires in an effort to recreate vitrification. These experiments revealed that producing temperatures high enough to melt granite is extremely difficult outside a furnace. Even when large amounts of wood are burned against stone structures, the heat tends to disperse quickly in the open air. Achieving the necessary temperatures requires enormous fuel loads and carefully controlled airflow. Replicating the effect across an entire wall, hundreds of meters long, would require a massive and coordinated effort. Another explanation suggests that vitrification may have occurred accidentally during the destruction of the fort. If the settlement were attacked and set on fire, timber structures within the walls might have burned intensely enough to generate extreme heat. Some Iron Age hill forts used wooden frameworks embedded within stone ramparts. If these internal beams caught fire, they might create localized conditions capable of producing vitrification in nearby stones. Yet this theory also raises questions. Most timber fires, even large uncontrolled ones, rarely reach the temperatures needed to melt granite. While localized hotspots can occur, maintaining temperatures above 1,000 degrees Celsius across extended sections of stone walls remains unlikely in ordinary fires. The vitrification at Tabula Peutingeriana therefore suggests either unusually intense burning conditions or a deliberate process designed to generate extreme heat. The mystery deepens when researchers consider the broader context. Tabula Peutingeriana is not the only vitrified fort in Scotland. Archaeologists have identified dozens of similar sites across the region, each showing evidence of stone walls that were exposed to intense heat. Yet outside Scotland and parts of northern Europe, vitrified forts are relatively rare. This uneven distribution suggests that the phenomenon may be linked to a specific cultural practice or building technique used by certain Iron Age communities. Recent surveys of Tabula Peutingeriana have also revealed that the hilltop fort was surrounded by a large settlement. Using LiDAR and aerial imaging, archaeologists discovered the remains of hundreds of small stone huts scattered across the slopes below the summit enclosure. This suggests that the hill may once have supported a large population, perhaps forming one of the most significant highland communities of its time. If so many people lived here, the vitrification of the fort's walls becomes even more mysterious. A fire hot enough to melt stone would likely have been a dramatic and destructive event. Another curious detail lies in the uneven pattern of vitrification. Some sections of the walls show heavy melting and fused rock, while other parts remain largely unaffected. This suggests that whatever process caused the vitrification may not have been evenly distributed across the entire structure. It is possible that certain areas contained stones with mineral compositions more prone to melting, or that fires were concentrated at specific points along the wall. Scientists continue to analyze the vitrified stones under microscopes in order to understand how they formed. Inside the rock, researchers find tiny bubbles, partially melted crystals, and glassy textures, clear signs that the material was once heated to extremely high temperatures before cooling again. These microscopic clues confirm that the stones of Tabula Peutingeriana experienced a thermal event far beyond the conditions normally associated with simple campfires or accidental burning. Today, the summit of Tabula Peutingeriana appears quiet and windswept, its ancient walls reduced to scattered stones that blend into the rugged Scottish landscape. Yet hidden within those stones is the evidence of a powerful transformation that occurred more than 2,000 years ago. The fused rock of the vitrified walls stands as a reminder that something extraordinary once happened here, something capable of generating the intense heat needed to melt solid stone. Despite decades of research, archaeologists have yet to fully explain how or why this process occurred. Whether the vitrification was the result of deliberate engineering, catastrophic destruction, ritual burning, or some unknown technique lost to history remains uncertain. What is clear, however, is that the vitrified fort of Tabula Peutingeriana continues to challenge modern understanding of ancient technology, and even today, as scientists examine the fused stones of its walls, one question continues to linger over the windswept summit of this ancient Scottish fort. How did people living more than 2 millennia ago manage to heat massive stone walls until they melted and fused together into a single solid structure? What do you think actually caused the stone walls of Tabula Peutingeriana to melt and fuse together more than 2,000 years ago? Share your thoughts in the comments below. The Ica engraved stones, also known as the ancient engraved stones of the Ica region in Peru, have long been one of the most intensely debated phenomena in 20th and 21st century archaeology. Ranging from small stones, only a few centimeters in size, to large blocks, weighing dozens of kilograms, all of them carry strange engravings, sometimes depicting humans living alongside creatures that went extinct tens of millions of years ago, and sometimes illustrating medical and astronomical techniques far beyond what is known from pre-Columbian civilizations. Yet the most astonishing and puzzling aspect for researchers lies in the very material on which these engravings were made: basalt and andesite types of stone that are extremely hard, durable, and difficult to work with, even using modern tools. And yet, on their surfaces appear fine, smooth, seamless, and remarkably uniform lines so precise that they look as though they were created with a highly advanced technology, surpassing the capabilities of ancient peoples. What do you think is the most reasonable explanation for how these ultra-smooth, perfectly even carvings were made? A lost technology, a special ancient technique, or something entirely different? Share your thoughts in the comments below. Your theory might give others something to think about. When examining the Ica stones, the first striking feature is the material itself. Basalt and andesite have high hardness levels and are commonly used in modern construction for structures requiring great durability. Even when heated, struck with heavy force, or carved with steel tools, these surfaces demand advanced skill to produce clean, sharp cuts. Yet in Ica, tens of thousands of stones of this type display engravings with consistent depth, without cracks, chips, or vibration marks, features normally associated with primitive carving methods. More remarkably, the engraved lines are unusually smooth, as though they were not carved with stone knives or rudimentary tools, but with a stable pressure engraving tip, or a form of precision grinding technology. Geologists who have examined these stones have admitted that the uniformity in depth, width, and smoothness of the carved grooves poses a major challenge to what any pre-metal civilization could have achieved. Many stones also contain soft, flowing curves that shift direction smoothly, showing no signs of hesitation, as would be expected when a craftsman pauses for breath or changes hand positions. If someone carved them manually, they would require exceptional skill and muscular stability, far beyond what ancient artisans typically possessed. Moreover, the number of stones discovered, over 15,000, makes the idea of a single master craftsman almost impossible. If only one person or a small group of artisans had made them, they would need decades, perhaps an entire lifetime, to produce such a large and uniformly detailed collection. Yet there is no evidence of any workshop of this kind ever existing in ancient Ica. One of the most mysterious aspects is the patina, the natural oxidization layer covering the stone surfaces. Some stones show engravings beneath the patina, indicating that the carvings have existed for a very long time before they were discovered. This greatly complicates the modern forgery theory, because for a patina layer to naturally form both on the surface and inside the engraved grooves, it would require hundreds or even thousands of years in the dry desert environment. If someone forged them in the 20th century, how could they have created such a naturally uniform oxidization layer? And more importantly, what tools did they use to carve extremely hard basalt while still producing smooth, sharp lines? Those who believe the stones are genuinely ancient argue that no rural craftsman in 20th century Peru could have possessed or created tools capable of carving basalt so beautifully, much less mass-producing them in such quantities. Furthermore, the variety of motifs, heart surgery, organ transplants, astronomical observations, and depictions of prehistoric animals requires an imagination and level of knowledge far beyond local folk traditions. They ask, did ancient peoples once possess a stone carving technology that we have not yet rediscovered? Or did they have a method for temporarily softening the stone's surface before carving some kind of chemical or thermal process that has been lost to time? Skeptics point out that several local artisans have admitted to forging some of the stones to sell to tourists. However, these confessions fail to explain the stones with thick natural patina or the exceptionally fine engravings that the artisans could not replicate when asked to do so under scientific observation. These impossible-to-fake stones deepen the mystery. Perhaps there are multiple categories of Ica stones, some forged, but others too sophisticated to dismiss as modern creations. Another unanswered question remains: if these stones truly originate from an ancient civilization, what were they created for? To record knowledge, to transmit technology, or simply to serve as symbolic or ritualistic artifacts? The engravings depicting surgery and astronomy suggest an unexpectedly advanced level of understanding. Meanwhile, the images of extinct animals challenge conventional history. Whether these images represent real ancient knowledge or simply symbolic art, the undeniable fact remains that the extremely hard basalt material, combined with the remarkably smooth engravings, has turned the Ica stones into a profound enigma. Today, with science more advanced than ever, we should have been able to decode these stones. Yet the deeper researchers investigate, the more baffling the mystery becomes. Specialists in geology, archaeology, material science, and even tool manufacturing engineering have examined the microscopic structure of the grooves. No one can say with certainty what kind of tool was used. The grooves show none of the micro-roughness left by metallic engraving tools. They also do not match laser marks, which cause burn patterns. The Ica grooves are cool sharp and show no signs of melting. Some scientists speculate that the creators may have used friction with a material harder than basalt, but materials harder than basalt today include diamond and carbide substances that would have been rare and extremely expensive for ancient peoples. So what truly happened in Ica hundreds or thousands of years ago, who carved these ultra-smooth lines into stones that are nearly impenetrable? What technology allowed them to maintain such precision and consistency that even modern methods struggle to replicate? And have we underestimated the technical abilities of ancient civilizations, abilities that may have vanished entirely from the historical record? To this day, the Ica engraved stones remain balanced on the thin line between truth and forgery, between science and myth, between what we know and what time has concealed. But regardless of the ultimate answer, one fact remains undeniable: the extremely hard stone material and the unusually smooth engravings form the core of this enduring mystery, an unopened doorway challenging every attempt at decipherment. And until humanity uncovers the truth, these stones will continue to rest beneath the Peruvian desert sun, carrying an ancient secret that modern science is still unable to unlock. The Sutton Hoo helmet has long been regarded as the supreme symbol of Anglo-Saxon culture, a relic that embodies both the majesty of power and secrets that have never been fully solved. When it was discovered within the Sutton Hoo ship burial, one of the most important archaeological discoveries in Europe, the helmet immediately became the centerpiece of academic attention. Not merely because of its rarity, its refinement, or its mythological motifs, but due to its unexpectedly complex technical structure, which far surpasses the craftsmanship level typically attributed to the Anglo-Saxon era. Do you think the extremely sophisticated craftsmanship of the Sutton Hoo helmet came from the Anglo-Saxons themselves, or was it influenced by another mysterious culture? Share your thoughts in the comments below. At first glance, the helmet astonishes viewers with its form resembling a warrior's mask, complete with metal eyebrows, nose and moustache, forged so meticulously that they resemble the head of a dragon from afar. Yet when archaeologists dismantled and reconstructed its surviving fragments, they discovered that its design was not merely symbolic or decorative. Beneath the surface lies a structural system so sophisticated that it raises a major question. How could the Anglo-Saxons have achieved such advanced metallurgical and structural joining techniques. According to restoration results from the British Museum, the helmet was constructed from multiple separate metal plates, each forged with its own curvature, then joined using precise riveting and welding techniques. This was not the simple method of hammering a single metal block into shape, as seen in most helmets of the era. Dividing the helmet into pieces and reintegrating them required calculating curvature, tensile strength, joint placement, load distribution, and especially a deep understanding of weight balance so the helmet would not shift or strain the wearer's skull. Remarkably, the plates reveal almost no visible seams. Once completed, the helmet appears as though it were forged from a single mass, suggesting the smith possessed a mastery of invisible jointing, a skill rare even in modern craftsmanship, let alone more than 14 centuries ago. The sophistication does not stop at structure. Decorative panels were inlaid and engraved using the niello technique, combining copper, lead, and sulfur to create a deep black contrast against reflective metal. These motifs depict warriors, horses, mythic creatures, and iconography, blending influences from Norse, Baltic, and broader northern traditions. To produce such work, the artisan needed precise command of heating, temperatures, metal expansion rates, niello adhesion, and controlled cooling, evidence of a metallurgical sophistication far beyond what traditional Anglo-Saxon history suggests. Unexpected technical complexity is what elevates the Sutton Hoo helmet art beyond the category of a typical funerary object. It raises a range of unanswered questions. Did the smith adopt techniques from Scandinavia? Did they inherit a long-lost artisanal lineage? Or was Sutton Hoo once a center of power, wealthy enough to cultivate metallurgical masters, whose work is now known only through fragments like this legendary helmet? Another remarkable feature is the helmet's near-perfect symmetry. The left and right sides mirror each other with extraordinary precision. The curvature aligns with the shape of a Northern European skull, and the mask plates fit tightly without obstructing vision. These qualities suggest the smith measured the wearer directly, or at least possessed advanced knowledge of human cranial proportions. Such individualized fitting was uncommon in the early medieval period, when most warriors used standardized helmets rather than custom-crafted ones. The helmet's sophistication extends into its protective engineering. The crown is reinforced with interlaced metal bands. The rear neck guard curves gracefully, yet remains impact-resistant. The cheek pieces allow head movement without friction, and the nasal ridge and moustache plates act as load-bearing beams, dispersing shock from frontal blows. These features echo Scandinavian helmet traditions of the 6th to 7th centuries, yet also integrate uniquely Anglo-Saxon elements, evidence of a cultural and technical hybridization poorly recorded in written history. Researchers were further baffled by the helmet's mechanical precision. Three-dimensional scans revealed remarkably uniform metal thickness across its plates. Achieving this requires controlled cycles of forging, hammering, heating, and cooling at a level many contemporary cultures likely could not match. Some theorists believe Sutton Hoo hosted a form of royal workshop staffed by elite metalworkers. Others suggest the techniques may have arrived from Swedish artisans associated with the Vendel tradition, a style strongly reflected in Sutton Hoo helmet's construction. Beyond technique, the enigma extends to the helmet's purpose. Although structurally solid, the piece is decorated so elaborately that it seems more ceremonial than practical. Yet certain marks indicate it was indeed used exposed to weathering and possibly combat. This creates a paradox. Why would an object of such royal, intricate, and expensive craftsmanship be taken into battle? To this day, no definitive explanation exists. Mystery deepens when considering the ship burial where the helmet was found. The Sutton Hoo grave is famous for containing no human remains only rich grave goods. Some scholars attribute this to acidic soil, dissolving the corpse. Others propose a more symbolic interpretation. Was this a cenotaph dedicated to a king, possibly Raedwald of East Anglia? If so, the helmet becomes an emblem of sovereignty. If not, the disappearance of the body adds another layer of mystery to the artifact, a royal object with an unknown ruler. The Sutton Hoo helmet is not merely an archaeological artifact, it is a historical riddle. Every plate, every engraved line bears evidence of an advanced technical tradition unrecorded in surviving texts. It breaks modern assumptions about Anglo-Saxon craftsmanship and opens the door to new theories regarding trade networks, cultural exchange, and the existence of master artisans whose legacies have vanished, except for masterpieces like this. Most importantly, the helmet's enduring power lies in its fusion of symbolism, authority, artistry, and engineering, forming a masterpiece humanity has yet to fully decipher. Perhaps the reason the Sutton Hoo helmet continues to captivate archaeologists, enthusiasts, and seekers of ancient mysteries is because behind those welded metal layers, behind the reconstructed warrior's face, lies a story from a past we believed we understood, yet clearly remains far more complex than expected. The helmet stands not only as proof of extraordinary skill, but also as a challenge to every researcher. Do we truly understand the Anglo-Saxons, or were they far more sophisticated than history has recorded? The Ustasevo idol is one of the most mysterious archaeological artifacts ever discovered in Siberia, and to this day it continues to spark debate among researchers about its true origins. This stone statue was found near the Taseva River in the Krasnoyarsk Krai region of Russia, a vast area of Siberia that for thousands of years served as a landscape where many different ancient communities lived, traveled, and interacted. From the moment it was discovered, the statue attracted significant attention from archaeologists because its appearance, carving style, and manufacturing techniques did not seem to match any known ancient artistic tradition in the region. It is precisely this difference that has made the Ustasevo idol one of the most intriguing mysteries in Eurasian archaeology. According to early estimates from researchers, the statue may have been created around 2,000 to 2,500 years ago during the early Iron Age in Siberia. However, determining the exact age of this artifact is far from simple. Unlike many archaeological objects that can be dated using radiocarbon analysis, the Ustasevo idol is carved entirely from a single block of stone and therefore contains no organic material that can be tested directly. Instead, archaeologists must rely on the surrounding sediment layers and other artifacts discovered within the same cultural strata to estimate when the statue might have appeared. Even this method, however, has not produced a definitive conclusion because the region has experienced many different phases of human occupation. Over thousands of years, multiple cultures have lived, migrated, or traded through this area, leaving behind a complex historical landscape made up of overlapping layers of evidence. Because of this, it remains possible that the statue could be even older than current estimates suggest. However, what truly makes the Ustasevo idol remarkable is not simply its age, but its unusual carving style. When researchers carefully examine the face of the statue, they notice that its features are carved in a distinctly uncommon way. The statue depicts a human face with large, deep eyes that are slightly elongated in an oval shape. The nose is prominently carved, extending clearly from the forehead downward in a long, straight ridge, giving the face a strong, structural form. The mouth appears as a short but sharply defined carved line, which adds a sense of expression to the face that is rarely seen in other ancient stone statues from the region. Altogether, these elements create a face that appears surprisingly individual and recognizable, rather than merely symbolic. This detail immediately surprised many scholars. In the ancient cultures known to have existed in Siberia, such as the Okunev culture, the Tagar culture, or the Scythian groups of the Eurasian steppe stone statues, usually follow a much simpler artistic tradition. These sculptures typically emphasize symbolic elements, such as body outlines, weapons, or ornaments, rather than detailed human facial features. Many statues only contain basic lines, suggesting a face, and rarely attempt to portray recognizable individual characteristics. Yet the Ust-Tasivo idol is completely different. The face of the statue feels almost like a stylized portrait, with proportions and features that appear carefully defined. This raises an important question for archaeologists. Did the people who created this statue belong to a different artistic tradition, or were they influenced by a culture from much farther away? The carving technique itself also adds to the mystery. The grooves forming the eyes, nose, and mouth are relatively sharp and precise, suggesting a careful and deliberate method of stone working. The surface of the stone, around the face, also appears to have been shaped and smoothed to create a more even plane. Considering that the statue may have stood exposed for more than 2 millennia in the harsh climate of Siberia, this level of detail is quite remarkable. It suggests that the creators of the statue may have possessed fairly advanced stone carving skills. This observation deepens the puzzle even further, because most other stone artifacts from the same region and period tend to appear much rougher in style. Some scholars have even suggested that the facial style of the Ust-Tasivo idol shows faint similarities to sculptural traditions found much farther to the west or south across Eurasia. In ancient history, migration routes and trade networks across the Eurasian steppe allowed ideas, techniques, and cultural symbols to travel across vast distances. Because of this, it is possible that the statue's carving style reflects some form of cultural exchange between different populations. However, so far, there is no clear archaeological evidence confirming this theory. Another detail that has drawn the attention of researchers is the possibility that the statue was altered at some point during its long history. Careful examination of the stone surface reveals that certain parts of the face appear to have been recarved or modified. These marks may have been made at a later time after the statue was originally created. This suggests that the Ust-Tasivo idol might have been reused or reinterpreted by different communities across generations. In many ancient cultures, the reuse of older monuments or statues was quite common. A later group might adjust certain features of an existing statue in order to align it with their own beliefs or symbolic traditions. The geographic location where the statue was discovered also adds complexity to the story. The Tasiva River region lies within a transitional zone between the Siberian taiga forests and the vast steppe regions of Eurasia. Throughout prehistoric and ancient times, this area likely served as a migration route for many groups of people, ranging from forest-dwelling hunter-gatherers to nomadic steppe communities. Cultural exchange and trade may have passed through this region for centuries. As a result, archaeologists have discovered traces of multiple cultures in the surrounding area. Yet this diversity also makes it more difficult to identify the precise cultural origin of the Ust-Tasivo idol. Even today, the true purpose of the statue remains uncertain. Some researchers believe it may have represented a deity or a protective spirit associated with an ancient community. In several Siberian traditions, erecting stone figures at sacred locations or along important travel routes was a common practice. Such statues might serve as religious symbols, territorial markers, or locations for ritual ceremonies. Others believe the statue may represent an ancestor or an important leader from an ancient group. In that case, the monument may have been created as a form of commemoration or honor. Regardless of which interpretation might eventually prove correct, the Ust-Tasivo idol continues to raise more questions than answers. Its exact age remains debated, its cultural origins are still uncertain, and its distinctive sculptural style has not been fully matched with any known artistic tradition of ancient Siberia. The combination of these factors has made the statue one of the most fascinating archaeological objects in the region. Today, the Ust-Tazevo idol stands not only as an archaeological artifact, but also as a reminder that much of ancient human history remains incomplete. Entire cultures may have existed, created monuments and works of art like this statue, and then disappeared, without leaving many written records behind. Yet through discoveries like the Ust-Tazevo idol, we are still able to glimpse fragments of that ancient world, a world that was complex, diverse, and still filled with mysteries waiting to be understood. Do you think the unique carving style of the Ust-Tazevo idol could be evidence that an ancient culture once existed here that we still know nothing about? Share your thoughts and theories in the comments below. Your idea might offer a completely new perspective on this ancient mystery. The Anubanini rock relief is one of the oldest and most mysterious surviving rock carvings from the ancient Mesopotamian region. The monument is carved directly into a rock cliff in Sapol-e-Zahab, western Iran, and is believed to date back roughly 4,300 years to the time of the Lulubai Kingdom, an ancient civilization that once inhabited the Zagros Mountains, but remains relatively little known today. Although the relief is not enormous compared to some of the world's most famous ancient stone monuments, what is carved into the rock surface displays a remarkable level of refinement and precision that has led archaeologists and historians to question the actual techniques used by ancient craftsmen. For more than 4 millennia, the relief has remained on the cliff face, enduring harsh weather, strong winds, rain temperature fluctuations, and the constant process of natural erosion. Yet what impresses researchers the most is not only its age, but the astonishing precision of the carved lines visible on the hard stone surface. In your opinion, how were craftsmen more than 4,000 years ago able to create such precise carvings on a natural rock cliff, using what we assume were relatively simple tools? Do you think they used a special technique? Or is it possible that we still do not fully understand the technology they possessed? Share your thoughts in the comments section below. The relief depicts King Anubanini, ruler of the Lulubai people, standing triumphantly over the body of a defeated enemy. In front of him stands the goddess Ishtar, the Mesopotamian deity associated with war and power, presenting the king with a symbol of authority. Beneath them is a row of bound prisoners, standing in line, awaiting their fate. This arrangement creates a clear visual hierarchy: divine authority at the top, the king at the center, and the defeated enemies below. However, when examining the stone surface more closely, what astonishes many researchers is not simply the story being told, but the way the story itself was carved into the rock. The carved lines forming the human figures, clothing, weapons, ropes, and facial details all show a relatively consistent depth, creating a clear relief effect against the natural stone background. This is particularly remarkable because the cliff surface was not a prepared flat plane like those used in later architectural works. Instead, it is a natural rock face, uneven, irregular, and composed of material that is not entirely uniform. Under such conditions, maintaining stable depth and clarity in the carved lines represents a significant technical challenge. Even with modern tools, carving a complex image onto a natural outdoor rock surface requires careful measurement marking and precise control of force. This leads to a critical question: how did the Lulubai accomplish this more than 4,000 years ago? Archaeologists suggest that ancient craftsmen may have used metal chisels and stone hammers, but what type of metal would have been hard enough to produce such stable carvings on rock? During that period, metallurgy was still relatively early in its development, relying mainly on copper or copper-based alloys. Such tools could carve softer stone, but producing clear and uniform carvings across a large surface would still have been extremely challenging. If one observes the details of the relief closely, the outlines of the figures appear fairly smooth, rather than composed of random rough chisel marks. This indicates that the craftsman had a high level of control over both the force and direction of the tool. Yet this raises another question: how could such control be achieved while working on an outdoor cliff face where lighting conditions change constantly and the stone surface itself is uneven? Another aspect that deepens the mystery of the technique is the consistency of geometric proportions. The figures in the relief do not appear significantly distorted despite being carved on a natural rock surface. This suggests that the craftsman may have used some method to maintain proportions while carving the images. In many other ancient civilizations, artists used proportional grids or preliminary markings before beginning the carving process. However, on the surface of the Anubanini relief, there is no clear evidence that such preliminary guidelines once existed. This raises another question: were the original markings removed during the finishing process, or was the craftsman truly capable of creating the entire composition purely through experience and visual estimation? Another notable feature is the continuity of the carved lines. When observing details such as the ropes linking the prisoners or the outlines of weapons and garments, the lines do not appear irregularly interrupted. Instead, they seem to have been executed in long, deliberate strokes. This suggests that the craftsman may have worked in a systematic sequence, perhaps beginning with the primary outlines and later deepening the carvings to create the relief effect. Yet this leads to another technical question. If the carving process occurred in multiple stages, how did the craftsman ensure that the depth and width of the carved lines remained consistent throughout the entire relief? There is also the issue of the working position. The relief is carved onto a nearly vertical rock face, several meters above the ground. This means the craftsman could not have worked as comfortably as when carving a stone block placed horizontally. They may have used a wooden scaffolding system or some form of temporary supporting structure to stand on while working. However, no clear archaeological traces of such structures have survived. If scaffolding did exist, it would have needed to be stable enough to allow the craftsman to perform precise carving movements over many days or even weeks. Yet if no scaffolding was used, the question remains: how did they access the carving surface at all? All of these factors make the precision of the carved lines in the Anubanini rock relief one of the most intriguing technical mysteries of ancient stone art. It suggests that the craftsmen of the Lullaby civilization may have possessed skills, techniques, or tools that we do not yet fully understand. Although the relief is often considered a predecessor to later rock carvings created by powerful empires such as the Assyrians and the Persians, its existence raises a deeper question about the development of stone carving technology in the region. Were the techniques used here part of a long artistic tradition that has since been lost to time, or do they represent a level of craftsmanship achieved through generations of accumulated experience? After more than 4 millennia, the relief of King Anubanini still stands on the cliffs of the Zagros Mountains, silently witnessing the passage of history. Its carved lines remain clear enough to tell a story about power war and religious belief in an ancient civilization. At the same time, however, they continue to raise questions about the tools, techniques, and working methods used by the people who created it. Perhaps it is precisely these unanswered questions that make the Anubanini rock relief one of the most mysterious ancient stone monuments in the world. Sweno stone has long been regarded as one of the strangest and most impressive ancient stone monuments still standing in northern Scotland. Towering near the town of Forres, this massive sandstone slab, rising more than 7 meters high, stands out not only because of its enormous size, but also because of the extremely complex carvings that cover its surface. Researchers believe the monument was created around the 9th century during the time of the Picts, a mysterious ancient culture that once lived in this region before gradually disappearing from history. However, what makes Sweno's stone truly remarkable is not only the historical story it may be recording, but also the very carving technique used to create the images on its surface. When examining each detail closely, it becomes clear that this monument seems to contain major questions about the technology and craftsmanship of ancient artisans, questions that modern science still has not fully explained. In your opinion, is Sweno's stone simply a monument recording history in stone? Or could it also be evidence that ancient people possessed carving techniques far more sophisticated than we currently understand? Share your thoughts in the comments section below. On one side of the stone, the battle scenes are carved in multiple registers, almost like a visual historical record. Warriors carrying shields and spears advance into combat, horses surge forward, and below them are scenes of prisoners being captured or executed. The entire composition resembles a story told in sequence, from the army entering the battlefield to the final outcome of the conflict. Archaeologists believe these images may be connected to a major battle between the Picts and invading forces from the south, possibly the Northumbrians. Yet even though the historical meaning of the carvings is still debated, one thing seems almost certain: the level of detail in these battle scenes goes far beyond what would normally be expected from stone carving of that era. Standing before Sweno's stone and examining the carvings closely, one can identify dozens of different figures, each carved in a distinct pose. Some warriors raise their weapons high, some ride horses charging into battle, and others appear bound after being captured. Round shields, long swords, and even the horses' reins are represented with notable clarity. This suggests that the artisan was not merely carving simple symbols, but was attempting to recreate an actual battle scene with astonishing detail. Yet the more carefully researchers observe, the more they realize that the greatest mystery of Sweno's stone may not lie in the subject of the carvings, but in the way they were made. One of the most surprising aspects of this monument is the unusual smoothness of the carved lines. Sandstone, although softer than many other stones, such as granite, is still a relatively hard material when carved across such a large surface. With the crude metal tools of the early medieval period, creating deep and clearly defined carvings would already have been a major challenge. But on Sweno's stone, many carved lines display features that have drawn the attention of archaeologists. They are fairly even in depth, sharply edged, and quite smooth inside the grooves themselves. When light strikes the surface from the side, these grooves cast distinct shadows, showing that they are not simply rough chisel marks. This raises an important question. What method did the Picts use to achieve such smoothness? If only iron chisels and hammers had been used, the carvings would normally retain the marks of individual blows, producing an uneven surface. Yet many details on Sweno's stone suggest that the grooves may have been smoothed or refined after the initial carving, as though an additional finishing process had been applied. Some researchers have suggested that the artisans may have used grinding techniques with harder stone or sand to smooth the carved lines. However, this theory has not been clearly proven, because polishing thousands of tiny details across a gigantic stone monument would have required an enormous amount of labor and time. In addition, when examined through methods such as raking light photography and surface scanning, researchers have noticed that many carved lines have a depth that is almost uniform along their full length. This is not easy to achieve. If the work was done entirely by hand on a vertical stone surface more than 7 meters high. To maintain such consistent depth, the artisan would have had to control the force and angle of each chisel strike with great precision. But how could that level of precision have been maintained throughout a carving process that may have lasted for months, perhaps even years? This remains an open question. Another theory suggests that before carving began, the artisans may have drawn out the entire composition on the stone surface first. This would have helped them position the figures and battle scenes accurately before starting to cut into the stone. However, even with a preliminary sketch, transforming a drawn line into a deep and smooth carved groove would still have required exceptional skill. This would have been especially difficult on a massive upright slab, where even a small mistake would have been extremely hard to correct. Furthermore, the height of Sweno's stone creates another major technical challenge. The carvings are not confined to the lower, easily reached sections, but extend upward almost to the top of the monument. This means the workers must have operated at several different heights, possibly using wooden scaffolding. Yet to this day, archaeologists have found no clear evidence of the scaffolding structure used during the carving process. If such scaffolding did exist, it would have had to be stable enough to allow artisans to carve precise lines onto the stone surface over a long period of time. Another aspect that fascinates researchers is the remarkable consistency of the carving style across the entire monument. The figures, weapons, and animals are all depicted in a highly uniform manner, as though they were created by the same group of highly skilled artisans. This suggests that the carving of Sweno's stone may have been a large and carefully organized project rather than a single work produced in an improvised way. All of these factors make Sweno's stone a particularly important case study in archaeology. It is not only a historical monument, but also evidence of the astonishing technical ability of the people who created it. At the same time, it reminds us that there is still much about the technology and craftsmanship of ancient civilizations that we do not truly understand. Even today, standing before this gigantic stone, many people still ask, how were artisans living more than 1,000 years ago able to create lines that were so smooth, deep, and precise on such a massive stone surface? Were they simply master craftsmen of extraordinary skill, or did they use technical methods that history failed to record? And if such methods once existed, why did they disappear without leaving any clear trace in later carving traditions? Sweno's stone still stands there through centuries of Scottish wind and rain, like a giant book made of stone. Its battle scenes still emerge clearly in the light, and the smooth carved lines continue to provoke thought among researchers. Because sometimes it is the smallest details, such as the unusual smoothness of a carved line in stone, that raise the biggest questions about human technical ability in the past. And until those questions are answered, Sweno's stone will remain one of the most compelling mysteries in the world of archaeology. The Samara alabaster figurines are among the most intriguing archaeological discoveries associated with the Samara culture, which existed in northern Mesopotamia between roughly 6,000 and 4,800 BCE. These small statues, usually only a few dozen centimeters tall, were carved from alabaster, a stone that is relatively soft, compared with many other rocks, but still requires refined craftsmanship to produce clear details and smooth surfaces. When archaeologists first uncovered these figurines at excavation sites in Iraq, they quickly realized that they were not merely simple prehistoric artworks. Instead, they appeared to reflect a level of technical skill and aesthetic awareness far beyond what is typically attributed to early agricultural societies of that period. The most striking aspect of the Samara alabaster figurines is the remarkably refined carving technique used to shape them. Although alabaster is softer than many other stones, it still requires stable, and precise tools to produce clean cuts. When closely examining the statues, researchers notice that the carved lines forming the face, eyes, nose, and body appear surprisingly smooth. These cuts do not look rough or jagged as one might expect from sculptures made using simple stone tools. Instead, they reveal a strong level of control over the material. Curved surfaces are shaped smoothly, edges are handled carefully, and the overall figure feels balanced and intentionally designed. This is precisely the point that has puzzled many researchers. Around 6000 BCE metal technology had not yet become widespread. Communities belonging to the Samara culture mainly used tools made of stone bone or very early copper. Such tools usually leave visible marks on stone surfaces, especially when craftsmen attempt to produce small details. However, many Samara alabaster figurines display relatively smooth surfaces and surprisingly precise carved lines. This has led some archaeologists to suggest that craftsmen of the time may have used abrasion and polishing techniques far more advanced than what we typically imagine for prehistoric technology. One hypothesis suggests that the Samara people used fine sand-powdered stone or natural minerals as abrasive materials. By combining harder tools with abrasive substances, they could gradually shape the alabaster and later polish its surface. However, such a process would require considerable patience and a deep understanding of the material's properties. Alabaster can easily crack or break if pressure is applied unevenly. Therefore, producing smooth curves and delicate details on these statues suggests that the craftsman possessed significant experience in working with this type of stone. When closely observing the eyes of many Samara figurines, the technical mystery becomes even more apparent. The eyes are often deeply carved and shaped like large almonds, sometimes occupying a substantial portion of the face. The outlines of the eyes are fairly even and sharply defined. This suggests that the craftsman had a high degree of control over their tools. In some cases, the surface surrounding the eyes appears smoother than other parts of the statue, creating a subtle contrast in texture. This is a refined artistic technique, indicating that the sculptors were not only concerned with form, but also with how light reflects from the stone's surface. Another element that adds to the mystery is the symmetry of the statues. Even though they were carved entirely by hand, many figurines maintain a relatively balanced proportion between the two sides of the body and face. This suggests that the craftsman may have relied on some form of observational or measurement system, even if it was very primitive. In later Mesopotamian cultures, artisans often followed traditional proportional rules when creating representations of gods or humans. However, for the Samara culture, we have almost no surviving evidence of such measurement systems or design guidelines. For this reason, the Samara alabaster figurines raise an intriguing question. Could these early agricultural communities have developed a sophisticated stoneworking tradition whose technical evidence has largely disappeared over time? It is also possible that such skills were transmitted orally from generation to generation without ever being written down. In many ancient societies, craft secrets were often preserved within families or specialized groups of artisans. If something similar occurred in Samara, then these alabaster figurines may represent rare surviving traces of a technical tradition that has otherwise been lost. Beyond the technical aspects, the shapes of the figurines also contribute to their mysterious character. Many statues feature large heads, oversized eyes, and heavily simplified bodies. These characteristics do not fully resemble realistic human anatomy. Some researchers believe this style may have symbolic meaning connected to the religious beliefs or mythology of the Samara people. In many ancient cultures, exaggerating certain body parts, especially the eyes, was a way to emphasize supernatural vision or spiritual awareness. However, because the Samara culture left behind no written records, the precise meaning of these figurines remains unknown. Another notable detail is that many figurines appear to have been carefully polished. When light strikes alabaster, a smooth surface can produce a subtle translucent glow that is characteristic of the stone. This effect makes the statues appear more vivid compared with rough stone surfaces. Achieving such a finish would likely require several stages of grinding, progressing from coarse to extremely fine abrasion. This process could take many hours or even days to complete for a single small statue. These alabaster figurines have also been discovered in various contexts, including residential areas and possible ritual locations. This has led archaeologists to propose multiple interpretations of their function. Some suggest they may represent deities or supernatural beings worshipped within households. Others believe they could depict ancestors or serve as protective ritual objects. However, because no written records from the Samara period have survived, the true purpose of these statues remains uncertain. All of these factors, refined carving techniques, carefully finished surfaces, stylized forms, and unclear purpose, have turned the Samara alabaster figurines into one of the most fascinating artifacts from prehistoric Mesopotamia. They are not only ancient works of art, but also rare clues about the technical abilities and symbolic thinking of people who lived more than 7,000 years ago. And even today, whenever researchers examine the smooth carved lines on alabaster, the same question continues to emerge. How did craftsmen of the Samara culture, working with tools that appear so primitive, manage to create stone sculptures of such remarkable precision? What do you think? How do you believe the ancient craftsmen of the Samara culture managed to create such precise alabaster sculptures with such limited tools? Share your thoughts and theories in the comments below. Your idea might offer a new perspective on one of the oldest artistic mysteries of ancient Mesopotamia. The Tabula Peutingeriana map is one of the strangest and most debated cartographic artifacts ever discovered from the ancient world. It is not a geographical map in the way we are familiar with today, but rather a long, narrow scroll map that stretches in an almost unusual format, depicting the vast transportation network of the Roman Empire from the Atlantic Ocean all the way to regions near India. The version that survives today is actually a copy redrawn around the 13th century, but most scholars believe its content originates from a much older Roman map, possibly compiled around the 4th century CE, and perhaps even based on sources that were older still. What makes the Tabula Peutingeriana so remarkable is not only its age, but also the way it was designed. A design that at first glance may appear to be a mistake or a completely illogical distortion. The map is nearly 7 meters long, but only about 30 centimeters tall. This means that the entire ancient world is compressed into an extremely long and narrow strip resembling a scroll rather than a conventional map. Oceans are squeezed into thin bands. Continents are stretched horizontally, and regions that are vast in reality appear heavily compressed and almost distorted. At first sight, this design seems to make little sense geographically. However, when researchers began examining it more carefully, they realized that the map was never intended to represent the physical shape of the world, but rather to illustrate the road network of the Roman Empire. When viewed from that perspective, the strange design suddenly becomes highly logical. Instead of representing terrain or territorial proportions, the map focuses almost entirely on roads stopping stations, cities, and the distances between them. In other words, it functions more like a transportation network map, similar to a modern subway map, rather than a traditional world map. What is truly astonishing is the level of detail contained within this system. Thousands of routes are drawn across the map as red lines stretching from one end of the scroll to the other. Along these routes are symbols marking cities, towns, fortresses, rest stations, and stopping points for travelers. In total, the map displays more than 500 cities and roughly 3,500 different locations. Along many of the roads are numbers indicating the distances between points typically measured in Roman miles. When archaeologists and modern geographers compared these numbers with the actual distances between known ancient locations, they discovered something remarkable. In many cases, the distances are surprisingly accurate, and some routes closely match what modern archaeology has confirmed. This makes the Tabula Peutingeriana not just an ancient map, but something closer to a transportation database of the entire empire. And this is where the mystery begins. The Roman Empire stretched across 3 continents, from Britain in the northwest to the Middle East and far into the eastern regions. To create a map representing such an enormous road network, the Romans would have needed an incredibly complex system for collecting data. They needed to know the locations of thousands of settlements, measure the distances between them, and then compile all of that information into a coherent system. In an era without satellites, global positioning systems, or modern cartography, accurately measuring distances between cities separated by hundreds or even thousands of kilometers would have been a massive undertaking. Some scholars believe the Romans used devices attached to wagons called hodometers, which counted wheel rotations to calculate the distance traveled. But even if that method was used, gathering and compiling data from thousands of roads across the empire would still have been an enormous administrative effort. This has led to the theory that the Roman Empire may have maintained a central mapping system where geographic data from different provinces was collected and standardized. If this is true, the Tabula Peutingeriana may represent only a summarized or copied version of a much larger mapping archive that once existed within the Roman world. However, no original map from such a system has ever been discovered. Another interesting feature is how cities are represented on the map. Rome appears as a prominent central symbol, while many other cities are depicted using different symbols depending on their importance. Some major cities are illustrated with small architectural drawings, while smaller locations are marked with simpler icons. This suggests that the map was not only a navigation tool, but also reflected the urban hierarchy of the Roman Empire. The map also extends beyond the official territories of Rome. It depicts routes and locations in Persia, Central Asia, and even stretches toward regions associated with India. This raises another question: where did the Romans obtain information about these distant lands? The knowledge may have come from merchants, diplomats, or travelers moving along trade routes, such as the Silk Road. Yet the level of detail shown in some areas still surprises researchers. Adding to the mystery, the original map upon which the Tabula Peutingeriana was based has completely vanished. The surviving copy is named after Konrad Peutinger, a German scholar of the 16th century, who once owned the map. However, the version he possessed was already a copy from several centuries earlier. This means what we see today is essentially a copy of a much older map. Each time the map was reproduced, small changes, copying errors or updates reflecting the knowledge of the time may have been introduced. As a result, an important question remains: what did the original map actually look like? And when exactly was it first created in Roman history? All of this makes the Tabula Peutingeriana one of the most important artifacts for understanding how the Romans viewed their world. It demonstrates that the empire not only built extraordinary roads, but may also have developed an advanced system for recording and managing geographic information. At the same time, it leaves many unanswered questions. How were they able to collect data across such a vast territory? who was responsible for compiling the original map? And could the Tabula Peutingeriana simply be the surviving fragment of a much more sophisticated ancient cartographic tradition that history has since lost? Even today, this long and narrow scroll continues to fascinate historians, archaeologists, and geographers, because behind its seemingly simple lines may lie evidence of a level of geographic knowledge and information management in the ancient world that we still do not fully understand. What do you think about the Tabula Peutingeriana? How were the Romans able to map such a vast network of roads with surprising accuracy across an entire empire? Could this map simply be the product of careful surveying and administration? Or might it be the surviving fragment of a much larger and more advanced mapping system that has been lost to history? Share your thoughts and theories in the comments below. Among the many ancient monuments scattered across the Indian subcontinent, few objects raise as many intriguing questions about early craftsmanship and cultural exchange as the Heliodorus column, also known as the Garuda Pillar, located at Besnagar near Vidisha, in present-day Madhya Pradesh, India. At first glance, the monument appears relatively simple, a tall stone column rising from the ground, weathered by more than 2 millennia of sun, wind, and rain. Yet carved into its surface are inscriptions that transform this monument from a simple pillar into a remarkable historical document. These inscriptions reveal that the column was erected in the 2nd century BCE by Heliodorus, a Greek ambassador from the Indo-Greek kingdom, serving under King Antialcidas, and dedicated to the Hindu god Vishnu. The pillar therefore represents one of the earliest known pieces of evidence showing interaction between the Greek world and the religious traditions of ancient India. However, beyond its historical importance, the monument raises fascinating questions about the technological capabilities of ancient stoneworkers, especially when one closely examines the astonishing precision of the Brahmi inscriptions carved into its surface. What do you think allowed ancient craftsmen to carve such precise Brahmi inscriptions into hard stone more than 2,000 years ago? Share your thoughts in the comments below. The stone used for the column is a dense variety of sandstone, a material that is far from easy to carve with simple tools. Despite this, the inscriptions on the Heliodorus column display an impressive level of refinement. The letters of the Brahmi script, one of the earliest writing systems of the Indian subcontinent, are cut into the stone with a clarity that remains visible even after more than 2,000 years of erosion. Each character is sharply defined, with clean edges and smooth internal curves. When examined closely, the lines appear deliberate and confident, not tentative or irregular. The depth of the carvings is surprisingly consistent from one letter to the next, suggesting that the craftsmen who created them had extraordinary control over both the tools and the material. Even more intriguing is the way the curved strokes of the Brahmi letters maintain a graceful symmetry. These curves do not look random or uneven. Instead, they resemble arcs drawn with careful planning. This raises an important question that archaeologists and historians continue to consider. How did ancient craftsmen achieve such controlled, precise lettering on hard stone using the relatively simple metal tools available at the time? To understand the mystery more clearly, it helps to imagine the process required to produce such an inscription. First, the stone surface would have needed to be prepared and smoothed. Any irregularities in the surface would make accurate carving difficult. After the surface was prepared, the letters would likely have been marked or sketched before carving began. But even this preliminary step raises questions. Did the craftsman use charcoal lines, ink, or shallow guide marks scratched into the stone? If so, how were these guidelines kept straight and evenly spaced along the cylindrical surface of a column? Carving on a flat slab is challenging enough, but carving evenly on a curved stone surface introduces additional complexity. The artisan would have needed to maintain consistent alignment of each line of text while working around the slight curvature of the pillar. Yet the inscriptions appear orderly and balanced, indicating that some form of careful planning must have taken place before the carving began. Once the layout was prepared, the actual carving process would begin. In ancient India during the 2nd century BCE, craftsmen typically used iron chisels and hammering tools to shape stone. While iron tools were certainly capable of carving sandstone, achieving the level of precision visible on the Heliodorus column would require exceptional skill. Each strike of the hammer would need to be controlled so that the chisel removed just the right amount of stone without damaging the surrounding surface. Too much force could cause cracks or unwanted chips. Too little force would produce shallow or uneven marks. The remarkable uniformity of the inscriptions suggests that the craftsman maintained a consistent technique throughout the entire carving process. The letters do not appear hurried or irregular. Instead, they look as though they were executed with patience and steady hands. Another fascinating aspect of the inscriptions is the smoothness of their interior surfaces. When light strikes the carved grooves, the inner faces of the letters appear surprisingly even. This implies that the craftsman may have used multiple stages of carving. The first stage could have involved rough cutting to establish the basic shape of each letter. After that, finer chisels may have been used to refine the edges and smooth the interior surfaces. Such a multi-stage carving process would require a high level of planning and discipline. It also suggests that the artisans responsible for the column were not merely laborers, but highly trained specialists who understood the behavior of stone under repeated tool strikes. Yet despite the apparent skill involved, the inscriptions also raise questions that remain difficult to answer with certainty. For example, the consistency of the letter depth across the entire inscription is striking. Maintaining uniform depth across dozens of characters would require careful judgment by the artisan. Without modern measuring tools, how did the craftsman ensure that each carved groove remained nearly the same depth? Was it purely the result of experience and practice, or did ancient stoneworkers employ simple measuring techniques that have not survived in the historical record? Some researchers suggest that skilled artisans might have relied on subtle visual cues or repeated tool angles to maintain consistency. Others speculate that the craftsman may have used marking techniques or shallow guide cuts before deepening the final inscription. The curvature of certain Brahmi letters introduces another puzzle. Many characters include graceful arcs that seem almost geometrically balanced. Creating such arcs freehand in stone is extremely difficult, especially when the artisan must carve them precisely while maintaining consistent width and depth. Did the craftsman use simple curved templates made from wood or metal to guide their work, or were these shapes drawn beforehand with careful measurement? The archaeological record does not provide a definitive answer, leaving historians to reconstruct the process through educated speculation. Beyond the technical mystery of the inscriptions themselves, the Heliodorus column also invites reflection on the broader context in which it was created. The fact that a Greek ambassador erected a monument dedicated to Vishnu indicates a remarkable degree of cultural interaction between the Hellenistic world and the Indian subcontinent. The inscription itself identifies Heliodorus as a devotee of Vishnu using the term Bhagavata. This suggests that the ambassador may have adopted local religious traditions during his time in India. If so, the pillar becomes more than just an inscription. It becomes evidence of cultural exchange occurring more than 2,000 years ago. The column stands as a silent witness to a time when ideas, beliefs, and artistic practices moved across vast distances, linking civilizations that modern history often treats as separate. The physical structure of the pillar itself adds another layer of fascination. Rising vertically from the ground, the column was carved from a single block of stone and topped with a capital that once supported a figure of Garuda, the mythical eagle associated with Vishnu. Constructing and erecting such a column would have required careful planning. The stone had to be quarried, shaped, transported, and then raised upright at the site. Each stage of this process demanded knowledge of stone-working techniques and mechanical principles. The fact that the pillar has remained standing for more than 2 millennia suggests that the builders understood how to balance weight and stability effectively. Still, it is the inscriptions that continue to capture the imagination of historians and archaeologists. The precision of the Brahmi script carved into the pillar offers a rare glimpse into the craftsmanship of ancient artisans. These letters were not merely functional markings, they were carefully executed statements meant to endure through time. Every stroke carved into the stone reflects the steady rhythm of hammer and chisel, guided by an artisan who likely spent years mastering the difficult art of stone inscription. Today, visitors who stand before the Heliodorus column often focus on the historical significance of the inscription, reading it as a message from the distant past. But if one looks more closely at the fine details of the carved letters, another story begins to emerge, a story about the hands that shaped the stone, the tools that struck its surface, and the technical knowledge that made such precision possible. Even after centuries of study, the pillar continues to inspire questions. How did ancient craftsmen achieve such remarkable control over their tools? What training did they undergo to develop these skills? And what methods did they use to plan and execute such delicate inscriptions on a curved stone surface? These questions suggest that the craftsmanship of ancient artisans may have been far more sophisticated than we often assume. The Heliodorus column is not only a historical monument, but also a testament to the remarkable technical skill of stoneworkers more than 2,000 years ago. Although researchers now understand much about the historical context of the pillar, the exact methods used to carve the sharp Brahmi inscriptions are still not fully explained. As a result, the column continues to preserve a quiet mystery of ancient stone carving technology. The Bath Sulis Curse. Tablets are among the most astonishing archaeological discoveries from the Roman period in the city of Bath, in England. These small lead tablets were discovered in the sacred hot spring area dedicated to the goddess Sulis Minerva, a deity that combined local Celtic beliefs with Roman religion. More than 130 tablets were excavated from the mud and mineral-rich waters of the ancient temple complex, and most of them carry engraved inscriptions containing curses directed at individuals believed to have committed crimes, particularly theft. However, what truly astonished researchers was not only the content of these ancient curses, but also the extremely sophisticated craftsmanship and engraving techniques used on the very thin sheets of lead. When archaeologists examined the tablets closely under microscopes, they realized that these were not simply pieces of metal hastily scratched with words. On their small surfaces appeared incredibly tiny, regular, and sharp inscriptions, revealing a level of tool control and craftsmanship far beyond what many people once imagined for ordinary individuals living in the frontier regions of the Roman Empire. Lead is a soft metal that deforms easily and can tear if uneven pressure is applied. Because of this engraving, letters on lead might appear simple at first glance, but in reality, it requires extremely precise control. When a sharp metal tool is dragged across the surface of lead, it can easily cut too deeply, tear the metal, or cause the sheet to bend and wrinkle. Yet, on many of the cursed tablets found at Bath, the engraved lines are thin, shallow, and remarkably consistent. Many of the characters are only a few millimeters tall, but each Latin letter can still be clearly recognized, including curved strokes and fine horizontal lines. This has led many researchers to ask an intriguing question: what kind of tools did ancient people use to create such tiny inscriptions on a soft material like lead while maintaining such remarkable precision? Some tablets also reveal an astonishing density of writing. The authors appear to have used every available space on the metal surface engraving new lines between older ones. In certain cases, the inscriptions overlap in different directions, as if the writer was attempting to squeeze as many curses as possible into an extremely limited area. What is particularly striking is that even in these crowded inscriptions, many letters remain clearly shaped and legible. This suggests that the engravers not only possessed considerable skill, but also had extraordinary control over the tools they used. Another fascinating question emerged when scientists began studying the tablet surfaces more closely using electron microscopes. Some engraved lines appear extremely smooth, showing almost no signs of hand vibration or tool slippage. Considering the dim lighting conditions of the ancient world, engraving letters this small on a thin metal sheet must have been a difficult task. This has led many researchers to wonder whether the engravers might have used specialized techniques or tools. It is possible that they employed very fine styluses or carefully sharpened metal instruments designed to produce narrow grooves while maintaining control over the pressure applied to the lead surface. Some scholars have suggested that the people responsible for carving these inscriptions may have been professionals with experience in writing or metal engraving. In Roman society, the professions of scribes and copyists were already well established, and it is possible that near the temple of Sulis Minerva there existed individuals who specialized in writing and engraving curse tablets for visitors. People who had lost possessions could come to the temple, explain their situation, and a skilled writer might engrave the curse on a lead tablet on their behalf. If this hypothesis is correct, then the curse tablets are not only evidence of ancient religious beliefs, but also traces of a specialized ritual service that may once have existed within the sacred temple complex. In addition to the remarkably fine engraving techniques, the tablets also display several other interesting technical features. After the curses were engraved, many tablets were folded multiple times, sometimes into small, compact blocks of metal. Some were even pierced with nails, or tightly rolled before being thrown into the sacred hot spring. Folding the lead tablets may have had ritual significance, functioning as a way of sealing a message intended for the gods. However, this action also posed a technical challenge. When a thin sheet of lead is folded repeatedly, it can easily tear or break. Yet many of these tablets have remained structurally intact even after nearly 2,000 years submerged in mineral-rich hot water. This suggests that ancient people may have had a surprisingly good understanding of the physical properties of the material they were working with. The content of the curses engraved on the lead tablets varies widely. Most of them relate to minor thefts such as stolen clothing, rings, coins, or personal belongings lost in the public bathhouses. The writers often ask the goddess Sulis Minerva to punish the thief with various forms of suffering, including sleeplessness, illness, or even death. Some curses even list multiple suspects, as if the writer was asking the goddess to determine the true culprit among them. Interestingly, not all of the tablets are written in standard Latin. Many contain grammatical mistakes, unusual spellings, or words that appear to originate from the local Celtic language. This reflects a multicultural society in which native inhabitants and Roman settlers lived side by side. In some cases, researchers have also identified strange symbols or sequences of letters that do not form clear words. These symbols may represent magical formulas or ritual expressions that modern scholars have not yet been able to fully interpret. In addition to engraved inscriptions, some tablets also contain traces of writing made with ink rather than carved directly into the metal. This ink has almost completely disappeared over time and can only be detected using specialized light analysis techniques. This raises the possibility that many tablets once contained additional messages that are now invisible to the naked eye. When viewed as a whole, the Bath Sulis curse tablets are not merely ancient curses written in anger or desperation. They also represent evidence of remarkably refined metalworking and engraving techniques. On these small sheets of lead, ancient people managed to create inscriptions so tiny and precise that they continue to astonish modern researchers. These technical details make the bath tablets one of the most intriguing archaeological artifacts from the Roman world. And perhaps the greatest question still remains unanswered: how are people living nearly 2,000 years ago able to engrave such incredibly small and precise letters on a soft, metal-like lead, without modern magnification tools, without advanced mechanical instruments, and often working under very limited lighting conditions? This question continues to puzzle researchers each time they hold one of these small lead tablets, each containing a mysterious message from the ancient world. How do you think people nearly 2,000 years ago were able to engrave such incredibly tiny and precise letters onto soft lead tablets without modern magnifying tools or advanced instruments? Do you believe this was simply the result of highly skilled craftsmen? Or could there have been forgotten techniques that we still do not fully understand today? Share your thoughts and theories in the comments below. Located in the Rouergue region in southern France, the menhirs of Saint Cernin are considered one of the most remarkable and mysterious groups of statue menhirs from prehistoric Europe. These massive stone monuments were erected roughly between 3,000 and 2,000 years before the Common Era, during the transitional period between the late Neolithic and the early Copper Age. At first glance, they may appear to be simple standing stones. However, a closer look reveals that their surfaces are carefully carved into human-like figures, displaying clear features such as faces, arms belts, weapons, and ornaments. These details have led archaeologists and researchers to ask significant questions about the technical knowledge, craftsmanship, and cultural capabilities of the prehistoric communities that created them. One of the most astonishing aspects of the menhirs of Saint Cernin is the remarkably precise carving technique used on very hard stone. Most of the statues are made from sandstone, a material that is relatively tough and not easy to shape using only primitive tools. Yet the surfaces of these stones display carvings that appear surprisingly smooth and well-defined. The grooves often have a consistent depth, the edges of the lines are clean, and many small details remain visible even after thousands of years of weathering. When light strikes the stone surface at an angle, the carved lines become clearly visible, almost as if they were produced by a sharp and carefully controlled tool handled with great skill. This becomes even more intriguing when considering the technological context of the period. Around the 3rd millennium BCE, most communities in this region primarily use stone tools such as stone axes, chisels, and implements made from bone or wood. While these tools could certainly cut or chip stone, producing grooves that are so uniform, smooth, and controlled, as seen on the statue menhirs of Saint Cernin, would have been extremely challenging. Some researchers suggest that the craftsmen may have used repeated grinding and pecking techniques over long periods of time, slowly shaping each groove little by little. However, when compared to other stone carvings from the same era, the level of refinement seen on the Saint Cernin statues appears significantly more advanced. Certain details on these stone figures are especially intriguing. For example, carvings representing belts, straps, or dagger handles are often depicted with parallel lines or small grooves running horizontally across the stone surface. These lines appear quite straight and evenly spaced, giving the impression that the carver had some method for controlling both spacing and direction with notable precision. In some cases, these smaller details are carved even deeper than the surrounding elements of the figure, making them stand out clearly despite centuries of erosion and weathering. This precision raises an important question. What kind of tools did prehistoric craftsmen use to create such carvings? If they relied solely on simple stone tools, carving smooth, and evenly spaced grooves into sandstone would have required immense patience and effort. Some scholars have suggested that early copper tools might have been used since metal technology began to appear in certain parts of Europe during this period. However, direct archaeological evidence confirming the use of metal tools in the creation of these particular statues remains limited. In addition, the arrangement of the carved features suggests a certain level of geometric planning. The face usually appears near the upper part of the stone, with the eyes represented by simple grooves or circular shapes. Below this lies the body, where elements such as belt straps or weapons are carved in relatively consistent positions. This pattern indicates that the carver was not simply working randomly, but may have followed a structured layout or traditional design template. Maintaining such balanced proportions on a large and irregular stone surface would have been a significant technical challenge, particularly without precise measuring instruments. Beyond the carving techniques, the stones themselves present another set of fascinating questions. Some of these menhirs weigh several tons, and they were likely quarried from stone sources located several kilometers away from their final positions. This means that prehistoric communities had to transport these enormous blocks across uneven terrain before carving or erecting them. Common theories suggest the use of wooden rollers, plant fiber ropes, or earthen ramps to move and raise the stones. However, direct archaeological evidence confirming these methods is scarce, leaving the exact process of transportation and erection partly unresolved. Another feature that makes the menhirs of Cernin particularly interesting is the depiction of weapons on the statues. Many statue menhirs show images of daggers or short swords positioned across the chest or along the side of the body. These carvings are not merely symbolic shapes. They often display recognizable forms with clearly defined hilts and blades. This suggests that the stone carvers carefully observed real weapons and attempted to reproduce them in stone. If this interpretation is correct, the statues may reflect important social roles within prehistoric communities, possibly representing warriors, leaders, or individuals of elevated status. Despite extensive research, the true purpose of the statue menhirs at Cernin remains uncertain. Some archaeologists believe they may represent ancestral figures erected to commemorate important individuals after death. Others propose that they functioned as territorial markers defining the boundaries or areas controlled by particular groups. Another theory suggests they were connected to religious rituals or ancient belief systems, with the human figures representing deities or protective spirits. Whatever their original purpose, the menhirs of Cernin demonstrate that prehistoric communities in this region possessed impressive technical skills. Selecting suitable stone, transporting massive blocks, organizing human-shaped compositions, and most notably, carving precise details into hard rock would all have required careful planning experience and craftsmanship. These achievements suggest that prehistoric societies were far more technically capable and organized than they are sometimes imagined to be. Today, when people stand before these statue menhirs, many still wonder how craftsmen more than 4,000 years ago managed to carve such clear and balanced designs into enormous stone blocks. What tools did they truly use? Where did they learn these techniques? And why did they devote so much effort to creating stone monuments shaped like human figures? These questions remain only partially answered. Yet it is precisely these unresolved mysteries that make the menhirs of Cernin one of the most fascinating prehistoric monuments in Europe, where each carved line in the stone seems to preserve a story about skill, ingenuity, and aspects of the ancient world that modern science is still striving to understand. What tools or techniques do you think prehistoric people used to carve such precise lines into these massive stones? Share your thoughts in the comments below. Across the vast grasslands of Central Asia, where the wind moves endlessly across the steppe and the horizon stretches without interruption, a series of ancient stone structures stand quietly against time. These are the Chimichek megalithic tombs archaeological monuments, dating back roughly 4,000 to 5,000 years, associated with what researchers now call the Chimichek culture. At first glance, they appear simple stone slabs arranged around burial chambers in the middle of remote landscapes. But as archaeologists began to study them more closely, these tombs revealed a number of puzzling characteristics that challenge our understanding of prehistoric engineering mobility and cultural exchange across Eurasia. One of the first mysteries lies in the scale of the stone construction itself. Many of the tombs are built using large megalithic slabs weighing hundreds of kilograms, sometimes more than a ton. These stones are placed upright to form a rectangular or square enclosure around a central burial chamber. In several cases, the tomb is also surrounded by additional rings or alignments of stones that create a larger ceremonial boundary. The arrangement may appear primitive from afar, yet the moment researchers examine the stones more carefully, an unexpected level of planning becomes evident. The slabs are not randomly placed. They are deliberately positioned to create symmetrical layouts, often forming clean geometric shapes that remain stable even after thousands of years of exposure to harsh steppe climates. This raises the first technical question: how were these stones transported? The Chimichek tombs are often located in open steppe regions, where large stone outcrops are not always nearby. Moving heavy slabs across such terrain without wheeled vehicles or advanced metal tools would have required careful organization, manpower, and possibly mechanical techniques that are not immediately obvious from the archaeological record. Did the builders drag the stones using wooden sleds? Did they rely on seasonal frozen ground to reduce friction? Or did they possess other transport methods that have simply left no trace? For now, the evidence remains incomplete. Another striking feature of the Chimichek tombs is the presence of anthropomorphic stone stelae, upright statues carved with simplified human features. These statues often display stylized faces, belts or weapons suggesting representations of individuals, perhaps ancestors, warriors, or symbolic guardians of the burial site. The artistic style is unusual for the region. Some scholars have noted that the figures bear surprising similarities to prehistoric stone statues found thousands of kilometers away in parts of Western Eurasia. If such similarities are more than coincidence, they might hint at ancient migration routes or cultural exchanges that connected distant regions of the Eurasian steppe long before written history. Yet even if such connections existed, the mechanism by which ideas and artistic tradition traveled across such vast distances remains an open question. However, among all the puzzles surrounding these monuments, perhaps the most technically intriguing aspect is the precision with which the stone structures themselves were erected. At the center of many Chimichek tombs lies a carefully constructed burial chamber formed by several large slabs set upright and fitted together to create a stable enclosure. These slabs are not simply leaned against one another. Instead, they are positioned so that their weight is balanced vertically, creating walls capable of supporting a heavy stone cap or mound above them. In some tombs, the stones appear to have been deliberately shaped or selected to match each other in height and thickness, producing a level of structural symmetry that would have required planning and measurement. For a culture that existed during the early Bronze Age, this level of construction precision is striking. The builders would have needed to understand how to position large slabs so that the structure would remain stable over time. Even small misalignments could cause the stones to tilt or collapse, especially in environments subject to seasonal temperature changes and soil movement. yet many Chimichek tombs have remained standing for thousands of years. This durability suggests that the builders possessed a practical understanding of weight distribution, ground stability, and structural balance. Whether this knowledge came from generations of architectural experimentation or from a tradition passed down through migrating communities is still debated. Another intriguing detail involves the vertical alignment of the stones. In several tombs, the slabs are arranged so that their faces align neatly along straight edges, forming what appears to be a deliberate geometric layout. Achieving such alignment without modern measuring tools would not have been simple. The builders may have used ropes, wooden frames, or simple surveying techniques to maintain straight lines and right angles. If that was the case, it implies that Bronze Age steppe communities had a more advanced understanding of spatial organization than is often assumed. Furthermore, the process of raising these stones into upright positions remains difficult to reconstruct. Each slab would have needed to be lifted from a horizontal transport position and carefully rotated into place without shattering or losing balance. This might have required ramps, earthen supports, or coordinated teams of workers using levers. Such techniques are known from other ancient megalithic cultures around the world. Yet clear physical evidence of the exact method used by the Chimichek builders has not been discovered. As a result, archaeologists can only propose plausible reconstructions rather than definitive explanations. Adding to the mystery is the fact that metal tools from the Chimichek culture appear relatively limited. While the Bronze Age name suggests the presence of metal technology, the archaeological record does not yet indicate the widespread use of heavy metal chisels or advanced quarrying equipment capable of shaping large stone slabs with high precision. This raises a fundamental question: were the stones carefully carved and shaped, or were they selected from natural formations that already possessed suitable flat surfaces? If the latter is true, the builders would have needed remarkable skill in identifying and extracting stones that could fit together structurally. The layout of many Chimichek tombs also hints at intentional spatial planning beyond simple burial needs. The outer rings, or stone enclosures, sometimes form symmetrical patterns around the central chamber, suggesting that the entire site may have been designed as a ceremonial or ritual space. Participants in funerary rites might have moved through these stone boundaries during rituals honoring the dead. If so, the precise placement of the stones may have served not only structural purposes, but also symbolic ones, defining sacred space within the open landscape of the steppe. When all of these elements are considered together, the transportation of massive stones, the careful geometric layout, the balanced vertical placement of slabs, and the long-term stability of the structures, a picture begins to emerge of a culture that possessed unexpected engineering competence. The Chimichek people were not merely stacking stones around graves. They were constructing carefully planned monuments that required organization, knowledge of materials, and coordinated labor. Yet despite these insights, several fundamental questions remain unanswered. How exactly did Bronze Age builders measure and align their structures with such consistency? What specific techniques allowed them to raise multi-ton slabs into vertical positions without advanced machinery? And perhaps most intriguingly, did the knowledge required for these constructions arise independently within the Chimichek culture? Or was it part of a broader tradition of megalithic engineering that spread across Eurasia through ancient migrations and cultural contact? For now, the Chimichek megalithic tombs continue to stand silently across the landscapes of Mongolia and the Xinjiang region, their stones weathered by centuries of wind and temperature. Each slab remains a physical record of decisions made thousands of years ago by builders whose identities are largely lost to time. The The tombs remind us that prehistoric societies often possessed levels of technical understanding that modern observers sometimes underestimate. And until new archaeological discoveries reveal more about the tools, techniques, and cultural networks of the Chimichek people, the precise engineering methods behind these remarkable stone monuments will remain one of the enduring mysteries of the ancient Eurasian steppe. If archaeologists still cannot accurately reconstruct the construction methods of the Chimichek megalithic tombs, what method do you think ancient builders used to raise these multi-ton stone slabs? Share your theory in the comments below. Your idea might be closer to the real answer than we think. Wakra Pukara is one of the most unusual and least widely known archaeological sites in the Andes of Peru. The complex sits on a mountain ridge more than 4,000 meters above sea level, surrounded by deep valleys and the steep cliffs of the Andes Mountains. From a distance, the entire site appears like an ancient fortress rising directly out of the mountain itself, with two natural rock formations projecting upward like enormous horns. This distinctive shape is what gave the site its name, Wakra Pukara, where Wakra in the Quechua language means horn and Pukara means fortress. However, when archaeologists began studying the site more carefully, they realized that it was not simply a military stronghold. Architectural remains, stone stairways, ceremonial plazas, and especially the sophisticated construction techniques suggest that Wakra Pukara may once have served as a ceremonial center or an important location within the cultural network of ancient Andean civilizations. One of the first things that astonishes researchers is the location of the structure itself. Wakra Pukara was built on a narrow mountain ridge, with deep cliffs dropping hundreds of meters on both sides. The terrain is extremely rugged, with steep rocky slopes and powerful winds that blow across the ridge throughout the year. Even reaching the site today with modern equipment can be a difficult journey. This naturally raises an important question. How were ancient builders able to transport construction materials to such an extreme altitude? The stone blocks used in the walls and platforms are not small, and the path leading to the ruins today consists mostly of narrow trails clinging to the mountainside. There is no clear evidence of large access roads or complex transport systems that modern engineers might expect for a construction project of this scale. This makes the logistics behind the creation of Wakra Pukara one of the earliest mysteries surrounding the site. Yet the most intriguing mystery of Wakra Pukara is not its location, but the construction technique used in its stone walls. In several parts of the complex, archaeologists have identified walls built in curved forms that closely follow the natural shape of the surrounding rock cliffs. These curves are not rough or accidental shapes created simply by adapting to the terrain. Instead, they appear carefully calculated, forming smooth arcs that are nearly perfect from a geometric perspective. The stones were carved and shaped so that they fit together with remarkable accuracy, forming walls that gently curve along the contours of the mountain. When viewed from above, these curves appear to be part of an intentional architectural layout rather than merely a practical adaptation to the landscape. What is particularly striking is that the stone blocks in these curved walls fit together so tightly that almost no gaps can be seen between them. In many places, there is no evidence of mortar or binding material. Instead, the stones were precisely cut, so they lock together through their weight and shape alone. This construction technique is often associated with the masonry style of the Inca civilization, but at Wakra Pukara, it appears in a particularly challenging form: curved stone walls. Creating stones that can assemble into a smooth, continuous curve requires extremely precise measurement and planning. Each stone must not only match the neighboring blocks, but also align perfectly with the overall curvature of the wall. A major question therefore arises: how were ancient stoneworkers able to achieve such a level of precision According to conventional theories, their tools were relatively simple, primarily stone hammers, chisels, and implements made from copper or bronze. While such tools are capable of shaping stone, producing flat surfaces and precise angles across hundreds of individual blocks, and then assembling them into a perfectly curved structure would have been an extraordinarily complex task. At Wakra Pukara, the contact surfaces between stones often appear nearly perfectly flat. Some edges are so sharp and well-defined that observers find it difficult to believe they were produced with such basic tools. Another fascinating observation emerges when following the curved walls along their entire length. The curvature remains remarkably consistent. This suggests that the builders may have used some form of surveying system or planning method to determine the wall's shape before construction began. In modern architecture, building a curved wall typically requires technical drawings, precise measurements, and sometimes specialized equipment to ensure the arc remains accurate throughout the structure. Yet, at Wakra Pukara, this appears to have been accomplished through entirely different means. Some researchers speculate that ancient builders may have used ropes, wooden stakes, or other simple measuring devices to define the radius of the curve before laying the stones. Even with such tools, however, shaping each stone to fit the intended curve would require exceptional skill and experience. A small error in a single block could disrupt the entire structure. And yet, when examining the walls of Wakra Pukara, such errors are rarely visible. The stones appear to have been prepared with astonishing precision before being placed into position. Constructing curved stone walls on a narrow mountain ridge would also have presented significant engineering challenges. The ground surface is uneven, and several sections of wall stand directly beside steep cliff edges. This means the builders had to work in extremely dangerous conditions while still maintaining remarkable accuracy when placing each stone block. Not only did they need to carve the stones precisely, but they also had to ensure that the entire structure remained stable on sloping terrain exposed to strong winds and extreme temperature fluctuations, typical of high-altitude environments in the Andes. Some archaeologists believe the curved walls may carry symbolic or ceremonial meaning in addition to their structural function. In many Andean cultures, architecture was designed to harmonize with the surrounding natural landscape. Curved forms may have mirrored the shapes of nearby mountains or reflected spiritual beliefs connected to the environment. If this interpretation is correct, the curved walls of Wakra Pukara were not merely technical solutions to difficult terrain, but part of a broader architectural vision, deeply tied to cultural and religious ideas. Even today, many questions about the construction techniques of Wakra Pukara remain unresolved. How did ancient builders measure and design curved walls with such precision? What exact methods did they use to cut stone blocks so that they fit together perfectly without mortar? And perhaps most importantly, how were they able to accomplish all of this on a narrow mountain ridge more than 4,000 meters above sea level under the harsh environmental conditions of the Andes? For these reasons, the curved walls of Wakra Pukara remain one of the most mysterious aspects of the site. They have stood for centuries, clinging to the mountainside as a testament to the extraordinary building skills of the people who created them. And although modern science has explained much about the ancient civilizations of the Andes, the precision and elegance of these curved walls continue to raise an enduring question. Have we truly understood the full extent of the engineering knowledge possessed by ancient builders? If ancient builders truly created the precisely curved stone walls of Wakra Pukara using only simple tools and without mortar, how do you think they achieved such remarkable accuracy on a mountain ridge over 4,000 meters high? Share your thoughts in the comments below. Perched on a massive sandstone cliff, rising more than 100 meters above the surrounding plains in Madhya Pradesh, India. Gwalior Fort has long been regarded as one of the most impressive fortresses on the Indian subcontinent. The complex has a history spanning more than a millennium and has passed through several ruling powers, from the Rajputs to the Delhi Sultanate and later the Mughal Empire. Yet among the many temples, palaces, and monumental walls within this vast fortress, one feature consistently captures the attention of archaeologists, art historians, and experts in ancient materials: the turquoise glazed tiles that cover the exterior of Man Singh Palace, a royal residence built in the late 15th century under the rule of King Man Singh Tomar. From a distance, the palace walls resemble a massive ceramic tapestry. Thousands of glazed tiles in shades of blue turquoise and yellow form decorative bands that run across the entire exterior of the building. These tiles depict elephants, peacocks, waterfowl, geometric patterns, and ornamental symbols that combine royal grandeur with elements drawn from nature. However, what astonishes researchers is not only their artistic beauty. What truly captures attention is the almost extraordinary durability of the ceramic glaze, which has survived for more than 5 centuries, despite the harsh climate of central India. For over 500 years, this region has endured intense natural forces. Summer temperatures can exceed 45 degrees Celsius, while powerful monsoon rains, dust-laden winds, and sharp temperature differences between day and night constantly attack exposed surfaces. Under such conditions, most decorative materials would quickly fade, crack, or detach from the walls. Yet many of the turquoise tiles of Gwalior Fort still retain their remarkably vivid colors. The glaze remains glossy, the blue tones remain deep and stable, and in some areas, the tiles appear almost unchanged from when they were first produced in the 15th century. For this reason, one of the greatest mysteries surrounding these tiles lies in the technology behind the extraordinarily durable blue ceramic glaze used by ancient craftsmen. In modern ceramic production, creating a stable blue or turquoise glaze requires precise control over the chemical composition of the glaze, the firing temperature, the duration of firing, and the atmosphere inside the kiln. Even a small deviation can alter the color, crack the glaze, or reduce its shine. Yet the artisans who built Man Singh Palace more than 5 centuries ago appear to have mastered a process comparable to perhaps even more refined than these modern techniques. Preliminary material analyses suggest that the glaze on the tiles may contain metallic compounds such as copper or cobalt elements commonly used in ceramic glazes to produce blue coloration. However, the exact proportions of these minerals and the way they were combined with clay and flux materials are still not fully understood. Some tile samples reveal a glaze structure that is highly stable and shows very few micro cracks, suggesting that the firing process was extremely well controlled. What makes this even more intriguing is that in the 15th century, precise temperature measuring technologies like modern kiln thermometers did not exist. How then were ancient craftsmen able to achieve the level of temperature control required to produce such a durable glaze? One hypothesis suggests that artisans accumulated knowledge through generations of experience developing techniques to estimate temperature by observing the color of flames, the glow of the kiln interior, and the behavior of the materials being fired. However, this explanation still does not fully account for why the turquoise color at Gwalior Fort appears so consistent and stable across thousands of individual tiles. In many other ancient ceramic sites, colors vary noticeably between firing batches. Here, however, the remarkable uniformity of the glaze suggests that the production process may have been standardized to a very high degree. Furthermore, the glaze on these tiles is not only beautiful, but also highly resistant to weathering. Over time, many stone surfaces of the fortress have experienced mild erosion from wind and rain, yet the ceramic glaze has proven far more resilient than expected. This raises questions about whether the glaze composition might contain particular minerals that increase hardness and resistance to environmental degradation. If so, ancient craftsmen may have possessed a deep understanding of local mineral properties and how to combine them to create an exceptionally durable, protective coating. Another aspect that deepens the mystery is the origin of this technology. Some historians believe that the technique of blue glazed tiles may have been influenced by Persian and Central Asian ceramic traditions, where Islamic architecture frequently used blue tile decorations. However, the tiles at Gwalior Fort display distinctly Indian stylistic elements, especially the representations of animals such as elephants and peacock symbols deeply rooted in local culture. This suggests that the technology may have been adapted, and further developed by local craftsmen into a unique regional form. Beyond the glaze itself, the structural precision of the tiles is also noteworthy. To create decorative bands that run continuously along the palace walls, each tile had to be produced with extremely accurate dimensions. During firing, ceramic materials typically shrink by a certain percentage. Without careful calculation, the tiles would not fit together correctly once fired. Yet at Mansingh Palace, the tiles join seamlessly to form animal figures and decorative patterns, stretching for tens of meters with almost no visible misalignment. This indicates that the craftsman not only mastered glazing techniques, but also understood the shrinkage behavior of ceramic materials during firing. Once completed, the tiles were attached to the fortress walls using a special type of mortar. Even after centuries, many of these tiles remain firmly fixed to the stone surfaces, despite the different expansion rates of stone and ceramic as temperatures fluctuate. This suggests that the mortar mixture may have been carefully formulated to absorb stress and prevent cracking. The exact composition of this ancient mortar remains uncertain, yet it clearly played an essential role in ensuring the long-term survival of the tiles. Today, when scientists study the turquoise tiles of Gwalior Fort, they see more than just a beautiful decorative feature from the past. They see evidence of an astonishing level of craftsmanship and material knowledge in the pre-modern world. While many aspects of this technology may be explained by generations of accumulated artisan experience, numerous details remain unclear. What exactly was the glaze formula? How precisely was the kiln temperature controlled? Why has the color remained so durable and consistent for centuries? These questions turn the Gwalior Fort's turquoise tiles into not merely an architectural decoration, but a technological mystery of history. They remind us that ancient civilizations may have possessed sophisticated material techniques that modern researchers are only beginning to fully understand. And along the ancient walls of Gwalior Fort, thousands of blue-glazed tiles continue to reflect the sunlight, quietly suggesting that part of the knowledge of the past is still waiting to be rediscovered. So what do you think about this mystery? How were craftsmen more than 500 years ago able to create turquoise ceramic tiles with such remarkable durability, consistent color, and precise craftsmanship using tools and technology far simpler than those available today? Was it simply the result of centuries of accumulated artisan knowledge, a lost ceramic formula, or could there be aspects of ancient material science that we still do not fully understand? Share your thoughts in the comments below. The Sanoli copper chariots are one of the most debated and attention-grabbing archaeological discoveries in South Asia in recent years. In 2018, during the excavation of an ancient burial site in the village of Sanoli in Uttar Pradesh, northern India, archaeologists uncovered a series of warrior graves, dated to around 2000 to 1800 BCE. Inside these graves, along with weapons helmets and many other metal artifacts, they discovered 3 ancient chariots buried with the deceased. However, what made this discovery remarkable was not only the presence of the chariots themselves, but the materials and manufacturing techniques used to construct them. The chariots found at Sanoli were covered almost entirely in copper, an extremely rare feature for vehicles from the Bronze Age. In most ancient civilizations, copper was a valuable material, typically used for weapons, knives, axes, jewelry, or small objects. Using this metal to cover a large and complex structure, such as a chariot, is rarely recorded. Yet at Sanoli, archaeologists found that many components of the vehicles, including the body of the chariot, the wheels and decorative elements, were covered with carefully crafted copper plates. These metal sheets were not rough pieces of copper, but relatively thin layers shaped to fit the structure of the chariot. They were attached to the wooden frame beneath, in a way that suggests the ancient craftsmen had a clear understanding of how to combine metal materials with organic structures. When archaeologists began cleaning the artifacts, they realized that the copper layer did not serve only as protection or reinforcement. The surfaces of the copper plates were engraved with intricate decorative patterns, including geometric designs, circular symbols believed to represent the sun, and other motifs that may have been connected to mythology or symbols of authority. The engraved lines are remarkably sharp and precise, indicating that the craftsmen had excellent control over their tools. This raises an important question for researchers: how were artisans nearly 4,000 years ago able to produce large, thin copper plates with such consistency while also carving complex decorative patterns onto their surfaces? In many contemporary cultures, producing large metal sheets was difficult due to limitations in metallurgical technology. Ancient smelting furnaces struggled to maintain stable temperatures, and controlling the thickness of metal during forging or casting was a complicated process. Yet the copper plates from Sanoli show evidence of fairly advanced metalworking. They appear to have relatively uniform thickness and were shaped carefully to match different parts of the chariot. This suggests that ancient craftsmen may have developed techniques of hammering, forging, or casting copper. Another notable point is the sheer amount of metal used. Copper was not easy to produce in ancient times. Creating it required mining ore, smelting it in high-temperature furnaces, and then casting or hammering it into desired forms. This process required significant labor and resources. For that reason, the use of large quantities of copper to cover a vehicle, such as a chariot, suggests that these objects held special value in the ancient society of Sanoli. Some researchers believe they may have belonged to elite warriors or members of a ruling class, with the copper plating serving as a symbol of power and status. However, this interpretation also raises another question. If the chariots were only symbolic or ceremonial, why were they constructed with structural features similar to vehicles that could actually move? Components such as the wheel axle, the chariot body, and the wooden frame indicate that they were not merely decorative objects. This leads to another possibility, that the chariots may have had both practical functions and symbolic meaning. The decorative patterns on the copper also show clear intentional arrangement. Many motifs are placed symmetrically and repeated in organized sequences. This suggests that the craftsmen were not engraving randomly, but may have used measuring techniques or templates to maintain consistency in the design. If this is true, then the ancient artisans of Sanoli may have employed design techniques or measuring tools that we do not yet fully understand. Beyond the copper covering, another feature that makes these chariots remarkable is the design of their wheels. In many ancient civilizations, such as Egypt or Mesopotamia, chariots typically used spoked wheels, a design that reduced weight and allowed vehicles to move faster. However, the wheels discovered at Sanoli were constructed as solid discs. This type of wheel is significantly heavier than spoked wheels, but is also stronger and more resistant to damage when traveling across rough terrain. The combination of solid wheels with copper plating greatly increased the overall weight of the chariot. Because of this, some researchers suggest that these vehicles may not have been designed primarily for speed, but rather for stability or strength. Nevertheless, their exact purpose remains unclear. In addition to the chariots, the Sanoli burial site contained numerous other metal artifacts, including copper helmets, shields, swords, and decorative plates. These items indicate that the ancient community living in this region possessed a significant level of metallurgical knowledge. The metal artifacts were crafted with considerable precision, suggesting that the craftsmen were capable of controlling casting and forging processes effectively. Some pieces also show evidence that metal was shaped into thin yet durable forms, a technique that requires a good understanding of material behavior and smelting temperatures. Another mystery surrounding the Sanoli chariots concerns the animals used to pull them. In many ancient civilizations, chariots were typically drawn by horses. However, evidence for the use of horses in this region, around 2,000 years before the Common Era, remains debated. Some researchers believe the chariots may have been pulled by oxen or similar animals, while others suggest they might have been associated with horses or another fast draft animal. If these chariots were truly designed for horses, it could mean that the use of horses in this region appeared much earlier than current historical interpretations suggest. Even today, the Sanoli copper chariots continue to raise many questions for archaeologists. How were ancient craftsmen able to produce large and thin copper plates with such precision? Were these chariots actually used in warfare, or were they primarily ceremonial objects? What animals were used to pull them? And most importantly, could the culture that created these chariots have reached a level of technological development that we still do not fully understand? The Sanoli chariots are not simply archaeological artifacts. They are rare clues left behind by an ancient civilization, and one that may have possessed metallurgical skills, craftsmanship, and mechanical knowledge far more advanced than modern historical assumptions once suggested. Until these mysteries are fully explained, the Sanoli copper chariots will remain one of the most fascinating puzzles in ancient archaeology. What do you think about the mysterious Sanoli copper chariots? Could these copper-covered chariots really have been used in ancient warfare, or were they primarily ceremonial symbols of power? And how do you think ancient craftsmen managed to produce such precise copper plates thousands of years ago? Share your thoughts and theories in the comments below.